about a minute, but I'm going to go ahead and introduce. This is Nick Floyd presenting. I'm not a developer, so I built and apologies. So I built an
Agentic.
agentic company anyway. Appreciate it.
There we go. There we go. Fantastic. All right, so morning everyone. My name's Nick, and as you can tell, my accent isn't really from these parts. Okay, a little bit foreign, but don't worry. If you don't understand what I'm saying, just stop me and ask, and I'll go back and try something else. Okay, but I want to get started with first of all telling you I'm not a developer, and I feel very out of my depth at this event, quite frankly. Okay, normally I'm the geekiest person in the room, but I feel like that's not going to be the case this weekend, which is great. Okay, which is really nice to see. So first of all, I am not a developer and I don't write code for our production side. Okay, that's the reality of it. Right, I am a trucks and sheds guy from 30 years ago. I used to work in warehouses, production lines, 24-hour, 7-day-a-week operations. Okay, before moving into consulting, eventually finding out about technology. And back in the day when I started, the computer was a room which had a green screen on it, and that was the computer, and nobody was allowed to touch it. Okay, whereas now, of course, the complete opposite, and that's actually some of what I'm going to be talking about today. So, first of all, how did I get started, and why did I decide to do this whole agentic thing anyway? And for someone who doesn't have a developer background at all, okay, no education whatsoever, okay, in development, computer science, none of it, okay. In fact, I left school at the age of 16 with almost no education at all, right. The best education, the best qualification I had when I left was my teacher who said I made the best fruit salad she'd ever had. That was it, okay, as far as my qualifications are concerned. So this has been quite a journey, and it started with this. Now, this is kind of a dirty word for people who have got a formal education in development and computer science, okay, vibe coding, okay, ooh, right, no one really likes it and no one really understands it, quite frankly, right, but that's how I got started, okay, almost actually a year to the day, actually a year just yesterday, when I actually started doing vibe coding, okay, and it was born out of frustration, okay, frustration at how long it took to do development, okay, how tedious it was to write the documents and how difficult it was to test and just how long the whole thing took, okay. As an entrepreneur in my own company, that's one of the things that used to drive me around the bend, okay, was why does everything take so long? So, I'd heard about this thing called vibe coding a year ago. Still a new thing, right? I didn't really know much about it, all right? So I was on a business trip, sitting in my hotel room Friday night, and decided to ask ChatGPT, what is vibe coding? Okay, and that's how it started. Okay, that's how it started, right? Literally a year ago, and I didn't sleep for 3 days. That's what happened. I literally stayed in that hotel room for 3 days and vibe coded, okay, for literally 3 days straight. I didn't sleep till Sunday night, okay, until I had something. Was it great? No. Did it work? Yeah, maybe, okay. If I didn't breathe on it, and I didn't look at it in a certain way, it kind of worked, okay, and that's how I got started. And it was fine. Okay, I came back into work on the Monday morning and got my team together, and by the way, I have a team of 50 people, right, of which I would say 47 of them have formal education in development. That's actually what we do. We do development as a company, okay. I don't, they do, but I have 47 people who do that. I came back in Monday morning and said, I got to show you guys something, right, and of course, well, that went down like a lead balloon, right. Where did this come from? Who did this? They're all looking at each other on the call. Who did this? Okay. And of course, then I was like, well, where's the repo for this? Can we take a look at it? What's going on under the hood here? Okay. I'm like, repo? What's a repo? Okay. I just vibe coded the whole thing over 3 days. Still didn't know what a repo was. Okay. GitHub? Yeah, okay. Heard of it. I know I pay a subscription every month. I see the bill. I'm not really sure what it did. Okay. So kind of a ghostly thing over here that no one really explains what the hell it is. Right? Okay. So of course, my lead developer, I gave him access to the repo, or gave him my password, and he got in and figured out how to give himself access to the repo, and then start digging around. Of course, ended up with a list of things of, well, this doesn't work, and this is not best practice, and this doesn't work. Okay, so then I got my sales director involved and said, hey, come and have a look. And she looked at it and she went, this is brilliant. Okay, this is fantastic. This is exactly what we need, right? So it's kind of interesting to me as to how we ended up in two very different worlds. Okay, a user who was extremely excited about what I had built, okay, versus a 47-person development team who was, quite frankly, very unenthusiastic about the CEO of the company vibe coding his way over 3 days to produce something. Okay, very unhappy about that whole thing. All right, but it was fine. Okay. Yeah, literally, this was me that Monday morning saying, yeah, it's fine. Okay. The other thing that I figured out is I didn't really know how it worked. That's one of the dangers of vibe coding, of course, is you don't actually know how it works. I didn't. Right? I knew it did things. Okay. I knew it had buttons. I knew it had colors. I knew it had some functionality. Kind of figured out the difference between some of the file types, but I didn't really know. Okay, so of course when something broke, I didn't know how to fix it. Okay, and when I wanted to do something new, okay, it was really difficult because I was literally building things on top of things on top of things when the thing at the bottom wasn't really the thing that should have been at the bottom. Okay, and of course, I did delete the entire database twice. Once, my fault, completely. Second time, cursor's fault. Okay? But it did say oops. In fairness, it did say oops. I probably shouldn't have done that. I'll warn you next time. So that's when we decided, or I decided at that point, I'm going to put a rule in place that says never, ever, ever run Prisma commands. I will do those. Okay? Even me, in my vibe coding state, figured out what Prisma was and the command you should never ever run on Prisma. Okay, twice deleted the database. First time, no users were on it. It was okay. Second time, we actually did have users. So then I had to very quickly figure out how to restore from a backup, which is also kind of fun. All right, let's keep going. My guess is that most people in the room have probably used AI at some point. Okay, whether it's ChatGPT, whether it's Gemini, whether it's Claude, whether it's Cursor, whatever. If you haven't used AI at any point and you're in this room, you're probably in the wrong place. Okay, but the reality is that most people are using AI, but that doesn't make you agentic. Now, a lot of people get confused about the difference between using AI and being agentic. And I've been using AI for a long time, way before I started vibe coding. Right? I was using AI. And agentic, though, is very different. AI is you are driving. Okay? You're asking a question, you're giving instruction, you're telling what you want, you're telling how to do things sometimes as well. Right? You're driving the AI, you're driving the conversation. You're correcting, you're course correcting, you're iterating. Okay? How many times do you just tell ChatGPT one thing, but then it's the next thing, it's the next thing, next thing, next thing, next thing, next thing. Right? Before you know it, right, the thing is as long as that. Okay? But that's using AI. It doesn't make you agentic. Using AI does not make you agentic. Okay? And this is the journey that we've been on really as a company for the last 12 months, okay, is me as a CEO being a vibe coder, moving my way through using AI, really using AI, then really, really using AI, okay, and then figuring out, actually, this is stupid, okay, this is really stupid, and there's got to be a better way of doing this, okay, and that's when the agentic thing kind of came together. The issue was there was a bottleneck in the entire process, okay, and it was really difficult to figure out, where is this bottleneck? Why can't we go faster? Why can't we do more? Why can't we go better, right, on what we have? Where is the bottleneck, right? And I figured out that the bottleneck was somewhere between the keyboard and the chair. When I eventually figured this out, right, that actually I'm the bottleneck, okay? And when I figured out that actually the human in the process is actually the bottleneck, okay? Let me explain a little bit what I mean by that. A human works on average 2,002 hours a year. Okay? That's what we work. We work a 5-day week, 8-hour day, right? 2,002 hours a year. Now, whilst you're doing that, certainly in my team, I can tell you my experience, for most of the day, maybe I was using AI maybe 3 or 4 hours out of that day. So let's just say half, just for the sake of math. Okay. So in an 8-hour day, I was using AI 4 hours. Okay, so across the week, it's 20 hours a week. Right, you multiply that up, it's 1,000 hours a year, fantastic, okay? I thought it was brilliant, right? 4 hours a day, wow, fantastic, right? But when you start working out, wait a minute, 4 hours a day, what is that, right, in terms of percentage? Not very much, right? So when you start working out, wait a minute, I'm really not being very productive here. I need to be running this for 8 hours a day while I'm here, so that's what I started doing. Get rid of all my meetings, do it for 8 hours. God, it was exhausting, okay? Then figured out, actually, maybe I can just work longer, okay? And get another 2, 3, 4 hours out of this thing, okay? And then I'll work a Saturday, and then I'll do Sunday, and it was how that was ending up, so I decided, this is stupid, we've got to figure this out, okay? And that's when I started using 2 computers. Okay, stupid, I know, right? But that's what I did. That's my way of doing it. Got a second computer, right? Okay, that didn't really work. So then I did 2 windows. Okay, did that. Then I figured out about agents. Okay, agents to help me. And I figured out that human, 2,002 hours a year, versus I could run 4 or 5 agents. Now what I'm doing is I'm multiplying my capacity effectively exponentially. Okay, so when you think about your efficiency, right, and what I got to was work out that I was about 5% efficient. Is where I was, okay, 5%, based on the capacity that was available to me. All right, so take the amount of time I was spending on it versus the available capacity based on running 5 agents, 24 hours a day, 7 days a week. Okay, I was about 5% efficient. So it was time to really change the way we worked, and the reality was, it was about how we define the work. It's how you line up the work. Then how do you give it to the things that are going to do the work? And actually, get out of the damn way of the work. That's one of the biggest issues, in fact, in becoming an agentic organization, is getting the human to step out of the way. Okay? And this is a huge shift in thinking from using AI to becoming agentic. It's the difference between building the engine and driving the car. Okay? Huge difference. If you want to drive the car, you can do that, but you can only drive the car 8 hours a day, 2,002 hours a year. Okay? That's all you can do. That's the reality of it, right? But if you build the engine and let someone else drive the car, you can keep building better and better engines. Okay? And that's really what an agentic organization is. Okay? Is about building the engine that allows the agents to do the work and get the human out of the way. Okay? So, what does that actually look like? Okay, it means outcomes. Instead of giving instructions, which is what a lot of people do with AI, is they give it very detailed instructions. I want you to get this CSV file, I want you to import it here, and I want you to do the thing, and then say, right, run. Off it goes. Okay, and we think we're agentic, but actually you're just getting in the way. right? Because guess what? You're reducing the power of what's available to you to this, right? Just tell it the outcome that you want. Don't tell it how. Give it the outcome. Give it the guardrails, the rules to operate in. Don't do this, don't delete the database. Okay? Never delete the database. Okay? Give it the rules, give it the guidelines, give it the training. Give it the outcome and get out of the way. The difference between driving the car versus building the engine. Okay? Now, if you can figure out how to do that, you let me know. Okay? I'm trying to get 50 people to do that. Okay? Right? We're literally a year into this journey, right? And we've made significant progress, I would say, right? But we've got a long way to go, right? But one of the things that we've been able to do is, let me just keep going here. One thing I should add here is about context. Now, the old adage used to be that content was king when you looked at things like marketing and knowledge management, or that's content was king. It's context is king now. Okay, context. It's absolutely the most important thing. Okay, doesn't matter which LLM you choose. Doesn't matter, right? Doesn't matter it's Cursor. Doesn't matter Gemini. Doesn't matter. Doesn't matter, right? What really matters is context. Context, all the time, every time. Okay. In every organization, about 95% of your context that lives in your organization gets lost every single day. Every single day. The phone call, the email, the message, the conversation you have, right? The problem you solve, the information, the knowledge, it gets lost, right? 95% of it gets lost. And I'll tell you where I got that number from, okay? Because when we started doing this, we created a tool called commitment capture, right? The idea was you're on a call with a client, you make a commitment, I'm going to do that, I'm going to send you that, right? You capture the commitment, okay? Average call for us is 25 minutes, average number of commitments captured was 5, okay? In each of those calls, okay? Because it relied on the human. Judging what is the right content and what isn't, okay? So we'll average 5 in a 25-minute call. So we created an agent to do the same thing, to attend the call, listen for commitments, and then record them for us, okay? And we went from an average of 5 to 18 on a 25-minute call, okay? So, 3x improvement. But then we realized that, wait, we're only getting 5 or 6 sets of commitments, client calls, every single day, right? But it covers literally for 50 people, right? 25 minutes calls, 5 of them a day, that's only not much time, okay? And you look at the amount of time that people are spending at work, wait a minute, what's happening with the rest of that time when the context is being generated? The conversations, the fixes, the bug fixes, the tickets, the specifications, the conversation at the work call gets lost, okay? So then we started having our agent attend every meeting, every one-to-one. Every conversation that happens in a company is quite remote, so every time someone picks up the phone, uses Roam to have a conversation, our AI is there. Every single one. Every single conversation. One-to-ones, briefing doc, everything. The AI is there. Okay. So we now capture around 100 what we call artifacts every day, okay, and we capture a ridiculous amount of data from that now. But our context has grown exponentially, and it means that we can now pass that context to the agents, and we can actually create much better solutions. Okay, much better solutions. Context is really important. All right, I'm going to keep going real quick because I'm getting the evils from over here. I'm taking too long. Okay. All right, talked about hours. We're not going to go over that again. Right. What is important here? Oh, let's get past some of the numbers that are boring. All right. What is important here is this thing called Dale. Now, what was interesting about people's adoption of our agents and our agentic method was it was still competition. Folks thought they had to compete with the AI. I can do better than that. My code's much. Oh, but you got that wrong. Okay, okay, screwed that up. Right? That people felt they had to compete with the AI. Okay, and so we had to figure out how to fix that. right? And one of the easiest things we did is we gave it a name. We called it Dale, right? So Dale is everything we are doing agentically is called Dale, right? So, oh, ask Dale. Get Dale to do that, right? Hey, is Dale in the room, right? So we call it Dale. It's actually a huge, huge part of the journey of becoming agentic is making it accessible to everybody. But more importantly, we split our teams into 2 humans and Dale. So our teams are actually 3-man teams. Okay, 2 humans and Dale now. That's how our teams are organized. So, and Dale isn't just one thing. Obviously, it's a huge mix of agents. We've got about 150 agents now across the business. Okay, we're adding probably at least 1 agent, 2 agents a day to the business. And the way we were able to do that is that we created an agent of agents. Okay, so we actually created the agent that creates the agents. Right, and it means now that everybody in the company is able to create their own agents. Doesn't matter who you are, developer, sales, doesn't matter. You can create your own agents. Plus, we created the agent that does the coding of the platform as well. Okay, so we have an agent that codes the platform. So you have a bug, you find the bug, you submit the bug, the agent picks it up, fixes the bug, tests the bug, releases the code. Okay, depending on the severity, either gets a human review or it doesn't. Most of the time, no human review. Okay, a bug is normally fixed and deployed, okay, within about 30 minutes. That's our average now. Okay, and we do about 30 releases a day on our GitHub now. Okay, I keep getting snotty emails from GitHub about our usage, but never mind. Okay, but we do about 30 releases a day on GitHub now, and I would say on average, half of those releases are from business people, not developers. So it's the sales manager who says, oh, I could really do with a column added to this report. They put that in his feedback, the agent picks it up, does the code, releases it, 20 minutes later, get an email or notification saying, hey, it's done, go check it out, right? And it's the business people that are now actually doing the coding by using the agents, okay? It's pretty impressive, right? It's a pretty impressive platform that we've built here, okay? But we've democratized access to the code. Every single person in our company, all 50 people, doesn't matter what you do, who you are, what level you're at, has full access to the repo, has a cursor account, okay, and can build their own code. They're not dependent on anyone. Our developers have changed roles. They now build the engine. They control the rules. They control the QA. They control the release cycle. They build the rules, not the code. Okay, then if something makes it into production and isn't right, okay, then something went wrong in our context. Go change the context. Don't go fix the code, change the context, then tell the agent go fix your code based on the new rules. Okay, a very different way of doing it, right? Keep your eye on the ball, but your hands off the wheel. Okay, very, very different way of doing it. Anyway, let's keep going. That's what we've done. All right, let's just keep going to the end because I'm going to get, sorry, yeah. So I didn't really learn how to code. I still don't know how to code. Okay, all right. I've done, I don't know, probably about 500 releases on our platform, but I still don't know how to code. Okay, but I'd challenge you to do this thing Monday morning. Pick a task you have to do every week, and I want you to train an agent to do it. I don't want you to write the instructions though. Just give it the outcome, give it the context, and let it go. See what happens. Let it go, right? Don't give it instructions. Give it outcome, give it context, and get out of the way. Okay? All right. Ah, yes. Got the end. Don't drive the car. Now, if any of you have any questions, we've got a few minutes left, and I'll also tell you this QR code. If you think you're agentic or you're going on the agentic journey, okay, we put together, our agent, Dale put together an assessment for you, okay, that you can actually answer the questions, and he'll tell you where he thinks you are, right? What strengths, weaknesses, things you should focus on, okay? There's one for you as an individual on your agentic journey, and there's also one for an organization. So if you're running a business or part of a business, it'll also tell you at an organization level where you are. So absolutely grab that QR code. Anyway, anybody got any questions? John, wow, yeah.
So what are your developers doing? You said you had 47 of them.
Yeah.
So what are they doing now that you've moved to agentic?
Yeah, so same things. They're still doing really building tools that the rest of the business is using to build the rest of our business. So obviously, you know, we serve our clients, so we do this for our clients as well, right? So they're helping our clients to do the same thing that we've done, okay? So moving our clients from whatever they're doing today into this agentic model, they're actually helping our clients do that. So, and it's actually really interesting because really, when you look at the roles have changed in the business now, right? Because you don't spend 8 hours a day, you know, thumping the keys. What they're actually doing now is much more customer focused, okay? And it's really interesting moving our development team to be put in front of the client. Used to think that was a really bad idea, right? Sometimes I think it still is from our developers, but actually it's worked out really well, to be honest, right? Because it means that they get to hear from the client in real time. So really the roles have become 3 things. You're going to be good at 2 of the 3 things in our company, that's either selling and supporting clients, developing code or managing the rule set, okay, and then consulting, right, solving problems. You've got to be good at those 3 things. So those guys really now are moving more into managing the rule set and the infrastructure of how it works rather than actually doing the code. About 96% of the code that runs our platform is written by AI. So only 4% is written by humans. And that's probably the janky stuff that I did on day 1. So.
Yeah, and I don't know if you can tell me this for proprietary reasons or not, but roughly what's your token cost, systems cost, you know, expenses of running the AI?
Yeah, good question. That's a great question. Okay. That's a great question. I do know the answer to that question, but what I will tell you, right, is it's constantly increasing, okay? And that's not a bad thing. All right. And I'll actually tell you that we set a very high limit we set a limit of $5,000 per employee per month on AI.
Okay, cool.
Okay? $5,000 per employee per month, and in my opinion, it's still way too low, right? If we're not spending that much money, if we don't spend that budget, then we're not doing our job right. We're not running enough agents, we're not running it hard enough, we're not running it fast enough, we're not solving enough problems, right? So $5,000 per employee per month is our budget, okay? We don't always hit it, okay? And that's a bad month as far as I'm concerned, right? Is that we don't hit that budget. So it's significant, right? But if you're not spending anything like that, you're probably not doing it right. Yeah.
I guess kind of 2 questions. One is, what is the worst bug that one of these agents has created for you that you've had to roll back? And how often do you have to roll back changes that the agents make and have a developer, you know, kind of pick up the pieces?
Yeah, great question. So on average, I would say we fix about 40 bugs a day. We introduce probably 4 bugs a day, and we roll back probably once or twice a week. Okay, it's not that much that we have to pull out of production. What I would say though is that we have a very good review system. So our agent, our QA agent, okay, that we have, makes a judgment call on severity, okay? We call it above the waterline, below the waterline, okay? Is this, you know, could this bring down the site? Yes, human review, okay? If it's not going to bring down the site, it's a UI, you know, button color or something, right? Then don't worry about it, let it go, right? So we do make that judgment call. We do still do human review, but only if it's above the waterline, and that's probably now less than 10% of our releases now go through human review, so less than 10%.
Do you have any issues with clients where they're concerned where their data is going or stored?
Yeah, we 100% do. Yeah, absolutely. And it's worth, because you've got to have that conversation on day 1, right? About, you know, what you're about to move into. Are you sure you're ready for this? Okay, what does it mean for your industry? We have clients who are HIPAA, for example. Okay, that's a big issue for them, and so we have to be really careful with that. We have to use some of their infrastructure. We work with all the big AI folks to make sure that yes, we're not included in learning models, etc. Right, they're keeping it themselves. We do got a couple of on-prem ones, but they don't work so well in reality. This industry's moving so fast. If you start doing stuff on-prem, it's moved, and you've done it. It's moved 3 times, right? So on-prem is really not the way to go. But you know, it's tough. Okay, it's really tough to get that right. But most of our clients, I would say, are running their own vector stores, hosted vector stores sometimes as well, okay? So they actually keep the embeddings themselves, okay? In their own embeddings, their own vector stores, they control a lot of that themselves. We're just connecting into it, putting and getting from there, right? That tends to be a better model for retaining that type of control. But we do have clients who are HIPAA, and we manage that well, PII information, all the rest of it. So it's very doable, okay? It is doable, and it, but the regulations and everything else haven't really caught up. So there's not a lot of guidance and frameworks out there either actually to help you with this. You've got to find your way through it. It's not easy. So it's possible, but it's not easy. Yeah, it's not most of it.
I was curious if you standardize around, you already kind of alluding to the fact that you don't, but like, is there one AI provider you're standardizing around in your organization? Kind of all over the board.
Yes, we are kind of all over the board.
Yeah,
and we were big OpenAI people for a long time, like the first 6 months, I would say, almost exclusively, I would say OpenAI. Then we brought Gemini into the mix, and then we brought Claude into the mix. And yeah, that's kind of, I would say, our three-legged horse right now is those.
So like not really like any of the open source models or any of that stuff?
No, we haven't ventured into that. Will we? Probably. We haven't. It's because we've been going so fast and hard at this. We've been kind of really using the established ones. So yeah, and back.
The code bases you have now in a post-AI world,
Yeah.
what quality are they? Are they even understandable by a human being?
Yeah.
And
Yeah,
how do
yeah,
you
yeah, absolutely.
ensure that they stay
Yeah.
good quality and don't just go a mess because the AI agents focus more on the outcome rather than the state of what it leaves the code base?
It's great question. The reason I'm smiling is because, again, I'm not a developer, okay? But sometimes I do look at the code and I go, okay? And I kind of go, it's like Matrix here. I'm not sure what I'm looking at, right? So when I started on my vibe coding way back a year ago, okay, I actually figured out really quickly that the tool was actually really, really good at putting comments in code, okay? And then referencing comments in Markdown documents. That was my big epiphany. I didn't know anything about Markdown until a year ago, right? That was a huge epiphany for me, right? And it actually was really good at referencing one versus the other, right? And so we actually built the agents to build its own documents as it went, okay? From the whole framing, problem statement, design, prompting, all the way through to build plans that we built into Markdown, to then what was done, roadmaps, all now in Markdown. We've actually probably got more Markdown documents than we have code, quite frankly, right? And so those documents is really living, breathing, and the agents manage their own documents. That's the thing. Change something, change the document. You need to learn something, go look at the document, right? If you want to build something next, put it in the document. There's a to-do, put it in the document, right? So that becomes that context I was talking about, and that's, again, I'm not kidding. I think we have more Markdown documents than we have code, right? And that's the reason why. So that's been hugely, hugely important for us. And as human, I would say as well, very important to be able to read what the hell's going on, right, and navigate the code. Yeah.
To build off of that question, in outcome-driven development,
Yeah.
if the implementation details don't matter, is anyone worried or looking at consistency between the various implementations of things that you have in the platform?
Yeah, absolutely. Yeah, no, it's a great point. And we actually do have an agent that does that, right? It will look for inconsistencies on, hey, you built this way, you did this one this way. Wait a minute, we need to establish a rule. Okay, we need to establish principles, some guidelines here of how this should work. We probably refactor, I'd say probably 5 to 10% of the platform every week. All right? Like literally 5 to 10% every week. Why? Because we establish a new guideline and then we spin up the agents to say, go implement the guideline across everything now. So that's part of the exercise, in fact, is that the code isn't stale because as we learn something, develop something, a new way of doing something, or a new guideline, never do this. Always add, descriptions to toast messages, for example, is one we recently did, right? Okay, and we refactored the whole site in overnight. Okay, find every single one, all 600 toast messages that we had or wherever it was, go do every single one really quickly, right? And we did it overnight with 10 sub-agents. So yeah, that rework, 5 to 10% of our site is refreshed every week because of it.
That'll have to be all for questions.
Okay. I am around for the whole weekend, so please do ask any questions. You feel free to take my contact details as well and reach out, and please do the survey. It's a fun thing to do. Excellent. Thank you.
Speaking of surveys,
There we go.
speaking of surveys, don't forget to do Linux Fest survey. It is on our website, lfnw.org, at any point today or tomorrow.
Thank you. Very good.
Awesome talk.
Okay, thanks.
The QR code all the way in the back.
Oh, yeah.
I didn't get
Oh, you
it.
didn't get it?
No.
Oh, come on. Thank you. Okay, thank you.
I always just snap a picture of it.
I tried.
And then once I get a photo, then it usually grabs it.
Oh, it does from the photo, okay.
Yeah, yeah.
Well,
In fact, I don't know if you can scan it from my phone.
Oh, there you go. Yes, you can do that. Yeah. That'll work.
Possibly, let me see.
That'll work.
Yeah, yeah. QR codes are crazy.
Yeah,
Like that.
well, let's check this out.
There you go.
Oh, look at
There you go.
Thank you.
that. There you go. Excellent.
You're in Silverdale?
Yes, we're in Pennsylvania. Yeah. Yeah, we just said it's local.
And you're all local?
No. Yeah. We have two resident offices over there with rest. We have a great
Where are we going? HC 108, so this isn't. We have 25 minutes.
I don't think so. Those are legible, not that one. I gotta do that one. No. Oh.
So you would know if you tried loading, like you tried installing a kernel module, or like if you tried building your kernel from scratch. Like if you went outside of your package manager to build something that wasn't in the kernel, then you would know if you had security enabled because you get error. Pretty sure I have. Okay.
About this
Sound check, late sound check. Test, test, test. Okay, it's working. Wait, that's good.
Yeah.
So that means the inputs are working.
Yeah.
I'm just wondering if you can hear me. Okay, thank you everyone.
Hi.
So, can I plug in here
Yes.
and get us going? All right. So this is it?
Yes, unless you have a different connector?
No, no.
Okay.
This is all good.
I am gonna do a few things with you really quick.
Sure.
One, how do you say your last name?
Gingerich.
Second, so how it generally works out is you have 30 minutes total, 15 minutes for your presentation, 15 minutes for questions at the end. You can go over either one, that's fine because the next one is 11:30. So you can go over either, but I will let you know that I will signal you that there's 5 minutes left of your talk, and or when there's 5 minutes left total.
Okay.
So I'll just do like this and catch your attention. Like upon my next catching your attention, I'll do like this, or however many minutes are left. So yeah, you're free to go over either though. But I'm gonna try to encourage you to not.
Yeah. Oh, absolutely. I think we'll be under 30 for the talk here.
Okay.
And yeah, I'm hoping to leave lots of question time. I think there will be some. Yeah. Cool. Yep. We'll just put it here. Oh, didn't like that one. All right, we'll try a different resolution then. That's okay. Don't worry. I think you just don't like. Yeah, 16 by 9 is better. 16 by 10, no good.
I'm just gonna be following Briar around.
Right there. No, it's no problem. I know we want some buffer time. It's good. I appreciate that for myself also. Yeah.
So I feel about it's time when I introduce you and you're talking. And then feel free to there's a camera as well.
Oh, yeah.
It is right here. It is right there.
Right here?
Yeah.
Okay. Cool.
Okay, yeah, you're in it. You're free to walk.
Can I just confirm when I'm in it and not in it?
You're in it currently.
Fully in it?
Okay, you're not fully in it anymore.
Would you like to move it
Yeah,
so
you can
that
move it
it's
however you
a
like,
bigger,
but-
wider?
Are the slides being recorded separately?
This is what it looks like right here.
Oh, okay. Well, I think I'm
This is
gonna-
being live streamed right now.
Okay.
And this is being recorded at the same time.
Okay, perfect. I'd probably, rather the camera be pointed a little more at me while I'm at my computer. That's gonna be just a bit easier for me. Is there a, clicker or otherwise? No, that's okay.
There's no
then
clicker.
I can just, okay.
Sorry.
Then this
You
is
wanna
totally
actually
fine.
type
Yeah,
that
I'll
right
just
here.
use the arrow
And
keys
face
on
it
my laptop.
Say that again, I'm sorry.
Oh, I'll just use the arrow keys on my laptop. That's fine. So yeah, as long as it's fine for me to be here, then that's good. And then I guess I don't obscure the slides.
Oh, you want to raise it up?
Yeah, because
Yeah,
otherwise
so
isn't
this-
it cutting them off? Ah, okay.
Yeah, it's got a log. I just figured this out right now, actually, so good. Oh, that's all the way up. So we'll have to lower it and then extend the legs. Do you want to extend that one for me? All the way to the bottom. Just try not to go with the cable. Is that all the way? Oh, it's not all the way. Oh, there you go. And then we'll take this. That looks like pretty good. Oh yeah, look at that. So now right there is good for you? And we got a little room to your left and much room to your right, so.
Okay, great, yep. That's good.
Thanks for
Right
coming.
on. Yeah, no problem.
Oh yeah, and then about the microphone. So it seems like it's picking up pretty well right now, so I don't have to do anything
You don't have
special
to do
to be
anything.
picked up by
No.
the microphone here?
You're good.
Okay, great.
And if ever that is not the case, we'll be handling it over here. You
Okay,
don't have to worry
yeah,
about
I'll
it.
try to keep my eye on you just in case, you know, you're like, no, we're not picking up anything.
No, it'll be okay.
Perfect.
Yeah. Actually, it's been pretty good. It's been picking people up in the hallway as well, so
Yeah.
that door will be closed
Uh-huh.
as well.
And it seems to pick up the questions as well. I think I saw in the last one it
Yes,
did pretty
it does
good.
pretty good, yeah.
Okay. All right, maybe I'll just remind people to speak up when they ask their question then. Okay.
Last name's Gingrich.
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 Yep.
Okay. I will not mess up names.
Oh, don't worry. It's fine. It's close. Yeah. Don't worry. I usually just try to use 3 syllables in it. That's mostly what I'm going for. Yeah. All right. So it looks like we got about 8 minutes.
Yes.
So I might sit down for a little bit then.
Oh, this
Yep.
is your chair, or you can
Oh,
sit
this
wherever
is
you
my
like.
chair. All right. Perfect.
You can move that wherever you like. Oops, I did not see that.
That's a bit of a strange translation of what was top of the screen.
Yeah, it was way worse last year, but it's better this year.
Uh-huh.
How good are we? 1, 2, 3, 4, 5, 6. Okay, 7. Start cutting people off. Oh, I didn't do
So I was just curious so I'm filling in for a talk for a colleague tomorrow, and is it the same kind of parameters for talks tomorrow? Okay, all right, so I prep appropriately. Yeah, great. That was prep, not the other word. That was, oh my goodness. I'm gonna have to try that again. The word, I'm not even gonna say it again. There we go, all right.
Oh, actually, let's see. I think that was. Yeah, I promise I'll bring it. So. Yeah. Isn't this literally the psychiatrist over there? Oh, yeah, that's fine.
Oh, okay. Oh, is there a chair? Yeah. As many people as there are chairs in our room. Oh, sorry.
That's okay. Dude, stay here. There's just where you want. Chair.
Yeah, there's one chair right there. Okay, you're welcome. Thank you. All right, I'll catch up with you after, okay? Yeah. No, not allowed to stand.
Fire.
Sorry, this room is actually all full.
Actually, one more. Right? You know that one, yeah, you know that one.
Are you sure? Yep. Okay. Oh, well, there's one seat available if you're wanting to. Okay, go ahead. No problem. Good morning, everyone. Welcome to Linux Fest. Today we will be listening to Denver Gordon and with the future of fixing technology, box theory. Enjoy.
So thanks for the introduction. So I work at Software Freedom Conservancy and I'm a director at another organization. My name is Denver Gingerich, and I'll be talking about box theory. So first, a little introduction about myself. So as I mentioned, I work at Software Freedom Conservancy. I'm the director of compliance there. And so the sorts of things that I do are ensure that companies are complying with various software right to repair licenses, also known as copyleft licenses, like the GPL, which is used by Linux. I also am the founder of JMP and also a current director of that organization. And we also believe software right to repair is very important. All of the software written by JMP can be repaired. You can do as you like with it. And so that's kind of just to set up, you know, where I'm coming at these issues from and the sorts of connections that I have to them. So to start us out, before I get into explaining box theory, I wanted to give us a history of personal technological autonomy. And so we'll start you know, at the beginning. And for a very long time, personal technological autonomy was inherent. Now, there wasn't a lot of technology. Maybe you were making a fire, or you were, you know, plowing a field or something like that with a horse. You know, things were not super complicated. You could mostly fix them yourself. Things were fairly straightforward. You could observe what the issue was, and then you could repair it. And maybe you couldn't repair it yourself, but someone close to you could repair it. Maybe there was a blacksmith in your town or something like that, and they could help you out. But generally, you were not very far from the repair needed to continue using the tools that you had. Now along came the Industrial Revolution, and then things became a bit less repairable because there were massive economies of scale, and in order to fix the device or to make a new one was very, very expensive. And so that started to really separate people from the repairing of their devices and therefore from their own personal technological autonomy. So in the 1910s, we had some revolutions in personal transportation technology, in particular the automobile. So the 1910s is around when the Model T became very popular, and it was quite amazing in a lot of ways because it was very repairable, and it was also very cheap. The price of the Model T, and this is inflation adjusted for today, was $5,000 in 2026 dollars. You cannot buy a new car for less than $20,000 today, any new car. And so this was the Model T, very repairable car for $5,000 of 2026 dollars. And so this was pretty cool, pretty nice, quite amazing that we had this technology for this relatively low price. And this really, you know, got a lot of people excited. And because Henry Ford was quite into engineering and repairability, the vehicle was therefore quite repairable. Now, in the 1920s, there were some other innovations, if you will. So one of the products of the Industrial Revolution was light bulbs. And light bulbs were great. They were relatively cheap and, you know, very useful. And so they were also not very repairable. If there was something wrong with your light bulb, you needed to buy a new one. And so the people who manufactured light bulbs saw this. They also saw that light bulbs were on average getting about 2,500 hours of life before you had to replace them. And they got together and they said, you know, 2,500 hours is a really long time. We think light bulbs should last for 1,000 hours instead. And so that's what they did, is they made light bulbs last for 1,000 hours instead. There were not very many manufacturers of light bulbs, and so they decided to make that decision, and it was great for them, but bad for everyone else. And so that is kind of how we got into kind of the first stages of planned obsolescence. And if you want to look that one up, it's called the Phoebus cartel. So then the other thing I wanted to note on planned obsolescence is another innovation. This one was made by Alfred P. Sloan, who headed a different car company. And Alfred P. Sloan's major innovation was the model year. He discovered that people, most of the people who wanted a car had one, so it was hard to sell new cars. And he decided that people should continue buying cars. And how to encourage people to do that? Well, you make a new model every single year and convince people that they have an old model and that they really need to get the new model. And so the new models weren't that different, but they were different enough that you couldn't easily share parts between different model years. And so this was the major innovation in cars in the 1920s, is the model year causing, basically inducing demand that was perhaps not necessary by adding the model year. So those were some of the things that were happening in the 1920s that were really kind of against personal technological autonomy. They were good for a few people, and I would posit bad for everyone else. So in the 1960s, fast forwarding a bit, we had software freedom, and it was a lot of software freedom, but it was a lot of software freedom only for a few people. These are people who worked at universities or worked at other organizations that were large enough for to have computers, and people would have software freedom because they didn't know anything else. You know, the code was there. Why would we not share it with other people? And so people would share tapes and other things. They would mail them around, and they would have as much software freedom as was possible at that time. You know, it wasn't, you know, you see a pull request and you merge it. You know, you send a tape with the code, and then they might send a tape back with some more code. And it could take a month or two just for the postal system to assist with your merge request. But this was pretty cool because we didn't have anything before that. So that was better than nothing. But it was, again, limited to just a few people. And so that was not awesome. But of course, as technology does, things changed. We got personal computers in the 1970s, and this was wonderful because lots more people could now have software and share it with their neighbors. And so at this time, the norm was still to share software with your neighbors. And people really liked doing this. I think most people like to share with their neighbors, and so that's what most people did. But some people don't. And in 1976, there was an open letter to hobbyists that was published. Some of you might be familiar with this. It was published by a man named Bill Gates. And he said, and to be clear, I'm paraphrasing, you should read the whole letter. But in short, what he said was, I don't want you sharing my software. You need to pay me for every copy of my software that you make. And I don't think hobbyists should be doing this. Stay away from my software unless you pay for it. So anyway, that was, you know, a restriction to people's personal technological autonomy because they had software that they now couldn't share with other people if they had got this software from Microsoft. So fast forward a little bit more, and we have some new threats to our personal technological autonomy. And broadly speaking, you can describe these threats as software tethering. So you may have some amount of software freedom. Maybe you can get some bits of source code, but you cannot install this code onto your devices, and these devices remain tethered through a network connection to the company that gave it to you. So one of these devices is a soundbar by Sonos, and in 2019 they released a firmware update that would brick your soundbar. And so why would you install this update? Well, you would install it so that you could get 30% off a new Sonos soundbar. And so this, you know, effectively created a huge amount of landfill waste because people were installing this update to brick their device to get this this discount, and that just seems, you know, wholly ridiculous to me. But there are many other examples, probably even more since I wrote this slide. There was the car thing by Spotify, which similarly depended on a Spotify service, and Spotify decided to shut down that service. So all of these car things became useless things after a little bit. Now, fortunately, people found ways to get around it and to install their own things onto them, but that doesn't always happen, and you know, most people don't know they can do that. So that's quite unfortunate, that situation. And then lastly, I wanted to mention the Echo by Amazon. So this is a device that will listen to what you're saying and then will perform actions based on that. And so one of the features it had when it came out is that if it was disconnected from the network, it could still do things. It could locally process your voice and take actions based on that. And then, you know, a thing you very well might want to do, because maybe you don't want to send all of your voice data to Amazon, but Amazon eventually decided through a firmware update that they would delete that feature and it would no longer allow you to locally process your voice. That information had to go to Amazon every time. And so this is another reason why we need personal technological autonomy. So anyway, that is a history of what we've gone through so far in this journey of fixing our technology, from it being quite easy to it becoming quite difficult. And there's nothing inherent about technological progress that means that things need to become more difficult for us to repair. There are a lot of reasons that we need to be able to still repair things. I'd like to summarize it as, if we don't have the means of production, we must have the means of repair. And so I think that's very crucial for us to have. Now, I want to turn things specifically now to software freedom and just kind of discuss a bit of what's going on here, because it kind of frames a little bit about this box theory concept I'm introducing. And one of them is that software freedom is not keeping up with technology changes. That is, you know, when we first had software freedom, computers they all kind of looked the same. They had a screen and a keyboard, some things like that. Computers look quite different today. They're like a little tiny thing with a screen and maybe a cellular radio, or they're like a car or like a tractor or something like that. So these computers are quite different, and we don't have all the same freedoms with a lot of these devices as we used to with these things that had a screen and a keyboard. And so that's one of the things. I actually wrote some of this kind of before a lot of and we can, you know, talk about the term, but the AI revolution, so to speak, happened. But that's another way that software freedom is not keeping up, is that we really need to be discussing these issues with how people are creating a new software from all of this free software, and discuss ways that we can improve on these processes. So the other thing is that software freedom is only available to a small fraction of people, like true software freedom in your device. That is people who have very specific models of ThinkPads or other things from long ago that aren't really supported anymore, and people who know how to write C code. Because if you don't have those things, you can't really make practical use of your software freedom, because there will be non-free bits of software here and there that you are unable to change. And so that's one of the things that I think we should really be looking at and really be looking to change, because I think there is a lot of opportunity there. And I did also want to note that this is indeed changing. So again, you know, when I wrote kind of the initial version of this here, this was before what I've coined the eternal November. So that's November 2025, when Anthropic released Opus, I think 4.5 or 4.6. And that was kind of like a bit of a watershed moment in terms of the usefulness of some of these tools really becoming much greater. And so I think a lot of people are seeing, and if you were at the talk that happened in this room in the last slot, this was discussed quite a bit. A lot of people are seeing that these tools, some of these, you know, LLM-based code generation tools or code assistance tools are becoming quite useful. And there are still a lot of issues with them in a lot of ways, but I think we should absolutely be talking about and thinking about how we can bring people into our free software communities to show them, how we can make people able to share and really collaborate on software, because I think that's one of the things that is missing in a lot of these discussions about the LLM-based coding assistance or code generation tools, is that people are like, great, now I have this program and I can do my own thing with it. Well, that's nice, and it's freedom in some sense for you, but I think part of the whole point of software freedom is that we're sharing things with other people, and I think it is difficult for a lot of these tools to make code that is really easily understandable by other people, and I think that's something we really need to work on, and that I hope we can. And so this is one of these glimmers of hope, with a lot of with a lot of bumps on the road ahead of us that I see, but I'm hopeful that we can bring software freedom to more people in this way and do that. So anyway, I just wanted to kind of set up where we are with the software freedom situation, and also note that software freedom is certainly necessary for personal technological autonomy, but it is not sufficient. So we should be considering, when a company says, oh, you're not allowed to actually change this bit or that bit of the device, and maybe that is you're not allowed to install something on your device. And that may be a violation of a copyleft license that they're using, but it is also a violation of your personal technological autonomy, regardless of whether it's a license violation or not. And so we should be telling companies that that's not okay. The device that I have is mine, and I can do with it what I want. So there are some precedents for personal technological autonomy, which I think are super helpful. The ones I'm going to list here are cars, trucks, and tractors. So we've had all of these things for well over 100 years at this point, and people have been repairing them for well over 100 years at this point. And really, not much bad has happened from that, and a whole lot of good has happened from that. Farmers are able to harvest their crops when they have to, and not whenever John Deere says they're allowed to harvest their crops. And there are a lot of people who are able to fix their own cars and trucks so that they can keep using them, perhaps beyond when some company thinks they should be using them. And the good precedent I'm talking about here is mainly about all of these people able to fix their own devices, and also importantly recognizing for these specific classes of technology that these are all very dangerous pieces of technology. They can do a lot of harm if used improperly, and also if fixed improperly. But somehow we have approached the point in society over this 100 and some years where we still think people should be able to fix all of these. And I think that is a good thing. And we've also, been able to determine that we can help frame the discussion through all of this because there are things like liability that have been well sorted out. From these. So, if you make a bad repair to your car or truck or tractor, it's on you. It's not going to go back to, Ford or whoever it is that made the tractor. They would like to claim that they can't let you use it because it will be bad for their brand. But I think people are smart enough to know that if you make a change to your device, car, truck, tractor, etc., and it causes a problem, that's not the manufacturer's fault. So I think this is a very important thing that we need to recognize and that we need to be talking about. So this really helps us frame the discussion here, and I would now like to introduce box theory to you. So I talked about cars, trucks, and tractors. Those are all boxes in a sense that people own and that I believe they should be able to fix. I have some more examples of boxes here. On the right, you will see boxes in the shape of phones, and then on the left, you will see a box in the shape of something else, which some of you can probably guess about what it is. And you can see some hands. I think they're probably from children there. I think it's great, that people learn from an early age how to repair their devices, how they work, etc. Of course, in a safe way. And it looks like that's what's being done on here. So yeah. So I will just say the words on the screen here, just so that we're all kind of on the same page about what I mean by box theory. And box theory says that there should be no limitations on how you can modify, change, adapt, repair, or fix a device in your possession. And to put it simply, within the four walls of that box, whether that box be shaped like a car, a truck, a phone, some sort of older, maybe VCR-like device, you should be able to fix it, and you should decide how it operates. And of course, if you do something wrong, that's on you, but you should have that right to do that. And I think this is a very good standard to have for what we think is acceptable in the society, and how we should talk to companies and legislators, etc. So there are a few things that come up when you think about this. One of the things that I was very intentional about on that slide is the word possession. So it's important to bring this up because a lot of companies will say, oh, well, we didn't sell you that box. We licensed it to you, or we leased it to you, or something else like that. You don't actually own it. And I think that's, for something that's within your possession, that is ridiculous. You should be able to do what you want with it. So that's why I use the word possession here, because I suspect companies are going to come along and say, oh, well, you can't have rights because you don't, because we've changed what the word own means. So I think this is really important here. The other thing is liability, which I talked about briefly before. And this is a question that has basically been solved already. Now, of course, cars are very dangerous, but in this case, I would like to say thanks to the work of people that have been, thanks to the people who've been doing work on these issues, because we do have very good precedents for repairing your cars and other vehicles like that. And so I'm very happy that we have good precedent on what happens when something goes wrong with a car repair, because we can very easily translate that onto other devices, which are, by the way, much less dangerous than cars. So box theory, importantly, is a multi-pronged approach, which is to say that it can be used in a lot of different ways. Some of the ways I envision people using it is, for example, if they are talking with legislators or other people, that are developing policy for things, we can explain this as an idea of the sort of boundaries we should have around the laws that we have, the sort of protections that should be written into laws. Laws should be pro-box theory, I would posit, because that is better for personal technological autonomy. And when people have personal technological autonomy, then they can interact much better with the world around them. Things are much more fair for people. They are less angry about the ways in which they are being controlled, because they have the control for themselves with the technology they have within their possession. And so that's one of the ways that we can use box theory. Another way that we can use it is, frankly, just in conversations with each other. I was talking with a relative about a certain type of car that had switched to a subscription model for its seat heaters. So you could buy this car, and you were not allowed to activate the seat heaters until you paid a subscription. And then, if you stop paying the subscription, your bum would stop being warm. And so this is quite a problem, I would say, because it removes the control of that device within your possession from you and puts it in the control of some other company. And so, we were talking about why does this bother you so much? And there was no really good way to describe that, like what the actual thing, the right was that is being taken away from you here. And I would say that this firmly violates box theory, because you should be able to control that. It's ridiculous for you to be paying to lug around this extra weight in these seat heaters that you are not allowed to use because you didn't pay some silly subscription fee that they made up. So this is the sort of thing that I'm talking about, where I think it's very helpful in these conversations. So it gives us a lot of things, I would say. It gives us, you know, a way to talk with legislators, with our friends and family, with other people that we want to talk about technology with and how technology is progressing and all of these other things. One other thing that I was thinking of is, for example, if you maybe work at like a software company or something, and you really want to make sure that your company is doing things to the benefit of the users. You know, if you were thinking about, say, starting a software developers union, you could include this as one of the things, like, I will not work on anything that violates box theory, because I think a lot of people feel like they're forced into working on things that are obviously against the rights of people, and there's maybe not an easy way to describe that. And so I would say that you should use box theory as a way of describing that, and I'm happy to chat more about ways that we can, you know, make it easy with a few sentences to explain what the concept is, you know, if there are ways to improve on what I mentioned. So I did want to now leave it up for some debugging time. So box theory is something relatively new that I've started talking about within the last year. And I had a lot of good discussions in previous times that I've talked about box theory because, you know, people highlight a lot of ways in which you know, there could be, you know, concerns around the edges. One of the things that came up was, well, what about companies that, like, they give you a phone that's glued together, and you know that's inherently difficult to repair because you need like a hot air gun or something like that in order to melt the glue, and then reattaching it is quite difficult. And so, you know, there are a lot of general concerns of this where things are being made intentionally less repairable, and maybe it's more difficult to legislate that. And so that's an example of the sort of issue that I want to talk about with all of you. I did want to note again that I work at Software Freedom Conservancy. We do have a booth in the G building here. If you would like to stop by, I'm happy to chat more with people there about this and other issues. I will also be giving a talk in place of my colleague tomorrow, who's unable to be here because he's sick, about the Vizio lawsuit that Software Freedom Conservancy is doing. So please come out here around the same time tomorrow, I believe also in this room. So check that out if you're interested. Please become a Software Freedom Conservancy sustainer if you like, and check out our booth for OpenWRT1s if you like those. That is a device we have that, in my opinion, respects box theory, as you can change whatever you want on it. And one of the reasons we made it is for that reason. So you can check it out and pick up one of those if you would like. So the slide source code is available for all of these slides, as you might expect for a presentation from me. Yeah, you can check it out there, and there's also the link to these slides right at the top. So I think that was all I had that I wanted to present to you, and now I would love to debug box theory or otherwise chat about personal technological autonomy and how we can improve that. So thanks very much, and also please speak up so the mic can hear you when you have a question. Thanks. All right. So I think the first hand I saw was over there.
Yeah, hi. I'll just stand up too, just to help out.
Thank you.
So I'm wondering, on the legislative side of things, aside from just calling our local senators and congresspeople, is there, what organization, what branch of the government does the pressure really need to go towards, so that those phone calls and time are, are there people who work on particular, groups? Is there an arm of the government that we should be calling, directing these questions towards, and asking, and also putting the the phrase box theory out there so we can better explain it to them and what it means in general?
Yeah, absolutely. So I would say that the major work right now being done on this in the U.S. in different legislative groups is in the states. Actually, there's a hearing on right to repair in Colorado on Monday about this. Basically, Cisco and other companies are saying well, basically everything we make is critical infrastructure, and you couldn't possibly repair critical infrastructure because you don't know how to do it, only we do. Also, the routers that we sell to small businesses and stuff are certainly critical infrastructure that, you know, are so sensitive to national security and all of these things. So anyway, if you want to learn more about Cisco's thoughts, you should, you know, remotely attend that hearing on Monday. But that's just one example of what's going on in Colorado State. I don't know the status of all of the bills in all of the different states, but there are organizations working on that, like the U.S. Public Interest Research Group, and there are generally public interest research groups, or PIRGs, that are in each of the states as well, like the Colorado PIRG, and then I believe there's a Washington State PIRG as well. So you should chat with those people, see how you can get involved, because they do have connections to the legislators and would know how to help out with that sort of thing. So they aren't, like, I do chat with people who work at these organizations on a somewhat regular basis, and you know, I'm still kind of introducing box theory to them, so they might not be, you know, fully familiar with it, but they're certainly on board with everything behind box theory. They believe strongly in the right to repair, and really want to promote that. So absolutely, you know, converse with them. Yeah. Yes, in front.
So do you see this as also being applicable to data? What I mean by that is you talked about physical boxes. What about access to and ownership and possession and, you know, ability to modify digital assets that we consume, books, media, music, video, etc.?
Mm-hmm. Yeah, it's interesting when you mentioned data there, because I thought where you were going was with kind of a data privacy angle, and I think that's an important thing as well. You know, I think that, you know, there are of course some issues with it, but like the GDPR in Europe attempts to solve some of these issues, and there's also a similar regulation in California where companies have to give you the data that they have on you when you ask them for it. And so I think this is a good way to go on the data privacy front. And then in terms of like books and things like that, I think one of the things I was sort of intentional about with box theory is that I was not kind of covering the you could call it like copyright concerns around things, because box theory you know, says that you can have full control of these devices, you know, but it doesn't mandate that you be forced to like or that you be able to necessarily share like a video that you have stored on it. And you know, I think that's a separate issue that we should absolutely talk about, but it's not something I wanted to you know, kind of glob onto box theory, because it's kind of a separate concern, and I think it is you know, important that we separate these sort of things for legislators so that they're able to more easily make these things happen, because I think that would get a lot more pushback if we tried to include that. Yeah. Yes, in the back corner.
Your point or analogy to the car repair issue and the culture and the legal aspect, I thought was a really great point that I've noted. Oh, thing with it is that a lot of the car culture was very strong then, right? And so that kind of permeated to now, where it's like makes sense that anyone, the owner of the car, can fix and modify and do whatever. But in terms of tech, there's definitely a lot less of that, right? And so my question to you is how to speak to normal people who use tech. You know, we have tech everywhere. How to speak to like right to repair that is actually good for them, even though they might not repair themselves, but it gives chance for repair shops to be available, so they get access to the actual parts and whatever, and so they could get it repaired there and not have to be stuck to just insert big company.
Yeah. So I think it sounded like there were a couple of questions in there, and one of them is about how we promote repair organizations and repair companies. like I was walking through a local mall yesterday, and I saw that they had a phone repair booth there, and I think that's a very common thing, and one we absolutely should promote and support as we can, because they're fixing screens and other things that make it so that you can keep using that phone. And one of the things that these groups are doing, like the public interest research groups, are making sure that people can have the access to the repair tools, the parts, etc., that are needed to do that. So I think that's super important, and that's another way we can support these sorts of groups, is by using those services and by talking to legislators or otherwise to make sure that they understand that we need these sorts of groups. And I think the other part of your question was about how to ensure that people are kind of aware of this, and I think this is partly also a generational thing. Like, I know my father fixed cars and trucks and tractors himself for a very long time, but he's kind of been stymied from doing that with more recent cars and trucks and tractors, not because they are less repairable, but because, and also not because they are more computerized, but because at the same time that companies made them more computerized, they also removed access to the repair information for those new parts. And so this wasn't, a natural thing that happened. It was the unnatural desires of the companies to, or you could say naturally they want to not let you do that. But anyway, it was them saying, no, you can't get that information anymore, because this is totally different, and it's very complicated. But it's not really. I know my father would have learned how to program if he could actually have used that to fix the cars, trucks, and tractors. But because that wouldn't help him, because they blocked his access to that, to making practical use of that, he won't. So I think, to answer your question, we do need to talk about these things. We absolutely need to pass on these stories between generations, so that people understand, what has happened in the past, and how it has changed, and how some of those changes may not be so great for us. Of course, there are a lot of good changes, good technological changes that have happened, but we also need to recognize when things are not going so well, and when they maybe were better in the past, and how we can port some of that into the future. So we should absolutely do that. And I did want to also note, one of the ways to show people how important repair can be, and especially the ability to install changes onto your own devices, is, and I'm not saying you have to do this or that you should necessarily, but if you're already using some of these AI tools, maybe one of the things you experiment with is say, hey, can you make my device do this thing that I want to do? And see what it says. Maybe it says, I can't do that because I don't know how to install something on this device. And well, why? Why don't you know how to do that? Like, what information could I give you to make that happen? And then keep pressing on it, and maybe let me know about what the result is, because that's a very helpful story for me to use when I'm talking to legislators or companies or other people, because it shows that people are trying to do this, they want to do this, but they can't. And it's not because they don't have the tools. The tools are very happy to do all of these things for them, but it's because the tools themselves tell them, oh, it's because the company is preventing me from doing this. And so I think that's very powerful, and I would really encourage people to do that, and to let me know about that. I will maybe put my email address on the screen later, but it's denver@sfconservancy.org if you want to email me that sort of a story.
That has to be our last question.
Okay, so this will be our last question here over there.
Maybe it's not a good last question. I wanted to play devil's advocate and ask about how box theory squares with modifications that an autonomous individual might make that are harmful. Like, I could come up with a bunch of them, but one of them, which fits in line with cars, is like modifying trucks for rolling coal, which, you create more pollution. I think that's objectively harmful.
Mm-hmm.
But people want to do it. Some people want to do it.
Mm-hmm.
So how does that fit with like box theory?
Yeah, absolutely. And I think that's exactly the sort of thing that I want to be tackling as part of, debugging box theory, is yes, people will absolutely do that sort of thing. And I think the way to tackle that sort of thing is to make it clear that that is not a sort of permissible thing you can do. So, you know, if you make that change and if it does cause increased emissions that are improper, then you are liable for that, and so you can be fined or otherwise. The important thing is that we should be legislating the actual harms and not the things that might eventually maybe lead to actual harms. And so I think that's really important, and there are a lot of ways that you can do that. For example, I live in British Columbia, and for a very long time we had a program called, I believe it was Air Care, and so it was a way of reducing emissions by regularly testing all of the vehicles that were older than a certain age to ensure that they you know, either had not developed problems or been modified to have emissions like that. So that's an example of a way that you could resolve this sort of an issue, is that sort of testing, or, you know, there's other ways you could do it if that is the goal. But the important thing is that you regulate the actual problem and not the things that can be used for many beneficial purposes, but maybe one day by one person for a bad thing. We regulate the bad thing and not the other parts.
Thank you.
So yeah, thank you very much, everyone. I'll be around. Feel free to come to the booth. Yeah, thanks so much for organizing.
No problem.
Yeah. Thanks. Yes.
Are you familiar with
Aptera, yes. I actually have a pre-order for Aptera.
Okay, so you understand.
Yeah.
Because I was thinking
mine
that
is
might be a
hard.
good point to bring up, you know, a car company that's trying to do the Tesla.
Yep.
Where it's subscription everything, different sources.
All right. Tomorrow.
Repair manuals.
So you away?
Yeah.
My uncle's
This
doing
proprietary
Oh yeah, absolutely. And or things like that. Like they're making like this fairly simple electric truck.
Yeah.
Like I think these are great. I think
Yeah.
part of the problem is these things are so
I'm also
complicated, and then they block us from repairing them also.
Right.
I think.
Yeah, and I wouldn't trust Amazon to be a good actor.
Sure.
Sorry.
Right. Totally.
I occasionally think the least, but I try to keep it to a minimum.
Yeah. Appreciate that. Good.
Really
comments.
appreciate it.
You're welcome. Happy to help. Sorry, I'm just gonna move over here just so I'm out of the way of any future presenter. Yeah, happy to take your question.
I'm curious.
Yeah, regulate the action. In fact, why should e-bikes be limited? Right, because you might
software
in a world where
that prevents you from changing hardware.
and you might need like in an emergency, like there might be a good reason to exceed the limit. But like if you're driving over 25 and a 25 speed limit, then maybe that's what should be.
Well, it should always be like,
Yes,
the e-bike
absolutely.
should still be flying with something.
Yeah.
You know, and maybe
I'm
it's
not.
like, I mean, I was, you know, when I went to Australia.
It is.
But maybe it's not the e-bike that should be limited, but the driving stuff.
Electronic insulin pumps.
Like, you can have an e-bike that can go 45 miles an hour, but you just
can
can't
basically
do it
go in,
unless it's a road.
because the
Well, I remember
frequency
too, like,
that
so when I was in Europe,
remote
the
uses
roads
is
are a lot
secure.
smaller.
So you can
And what
essentially
they
hook
do
it
is
up
they
to
make
like
a lot of
any
space
TV remote.
Yeah.
for
But you can
walkers
also
and
hook it up
bikers,
to,
but the
you can
walking
use
and
that to
biking
hook it up to
is lane
continuous,
separate too.
like
We
Yeah,
have a
that's-
plant that goes down the
bridge code.
or something that.
But if you
that
try to
indicates,
fix
like,
the
this
security
belongs right
for
next to the
your
bike
braking
lane.
dams.
And so then the
Yeah,
bikes
you
are.
should also
because I
check
made a
out
mistake and
the
you know,
Lfnw
different, and I was like,
Foundation,
yeah, somebody's like, you're not in the bike lane.
FULU.org.
Yeah, we have that.
Because they're working on this sort of thing. They basically have bought
Yeah, but I,
bounties.
yeah, I've seen more of those.
But
Please
it doesn't
break the
work
DMCA.
because
Also,
people
please don't,
cause-
if
Well,
you're
because they're
worried
still
about
very
legal
small.
liability,
They're still
but
about the
in
size of
one
this.
and they're
cases
very close.
that
Yeah,
they,
like, they're
where
talking
this
about
is shown to
this
be
size
very
of this
beneficial,
road is
and
just
they are willing to, you know, basically
Yeah.
sue
Yeah,
about
I think
this
in
to
some
break down that part of the
European countries
DMCA.
do things a lot better.
Yeah,
Hello.
One of the
but again, why don't we?
Hey,
do it?
doing great.
So we're trying to
Okay, so we're going to log into the
system here.
And the
Sounds like
exceptions
you're,
also change every 3 years, you know,
Oh,
every
yeah.
July.
That is why the cars, like, this is so interesting, because I was.
You are our
I
first
just,
speaker.
I knew that was my thing, and I know that there was. And I was really torn on someone investing in the Subaru.
Yeah, I know.
There's someone like everything else, actually flashing something secure and public. Have software, this was second time the software, they either didn't tool from the cars are super expensive, like, and everything is like, everything that you're doing is being pushed back to the car manufacturer.
Yeah, I'll be at the booth, the Conservancy booth as well, if you have more questions, I just wanted to take, I think there might be one behind you, so, yeah.
Like, issues that go along with that.
Oh, yeah, okay, perfect, so I'm getting down there.
Like, just disrespectful, like.
What do you do for work?
Oh, I'm a student right now, but I just have this, it's like, you know, it's like everyone who does something and it's always about
And if you want to share your screen.
Yeah, those are, my daughter has one and that's one, she's had one before and that's one of the reasons she just, yeah, they're very frightening.
I have a tool, which I did with lost yet, called Cyborg. IoT devices.
So now we have a sub that doesn't know anything.
He started out here doing self. I'm sure it's self. He still does not really know anything.
Dwayne, can you hear us?
Yes.
Yeah, I can hear you guys fine. Can you hear me?
Yeah, we just gotta get.
I mean, you're coming in a little quiet, but that's, I think, normal with the.
Kiara, can we hear
Can you go ahead and say anything?
The example make functions.
I can hear you.
Do you want me to speak?
Yes, please.
Oh, okay, yeah, testing. I can barely hear you now.
I can hear
You're far away from the mic.
Just want to say, are you doing the repetitive?
That sounds like you're muted.
So, probably put a good idea to close the door once it starts, because,
Yeah, I can close the door.
oh, perfect, so you're way ahead of me.
I closed the door, I felt cold, I was cold, I was bored, but just walked right in.
Yeah.
It's like, oh yeah.
Yeah, I know. It's alright. As long as people aren't causing problems, that's the main thing.
Everyone's been very.
Your cell phone is super faint.
Yeah, it's like, direct them to the website is the work adventure link, they can watch it online.
There.
So if you go lfnw.org,
through the
pull it up, I'll show you.
So we'll go on.
Super quiet.
What are all your links? lfnw.org, and it's just join work adventure at the top of the screen, and it'll open up a new window. They can check it out, they can walk around with live streams, or it's like a virtual space and watch on YouTube. Otherwise, if they don't want to use that, they can go to the photo, and it's a YouTube link. They can go to the YouTube channel. Oh, sounds
Yeah,
good.
that's good.
Are you the one from Olympic College?
Yes, ma'am.
And you have
I'm Valerie.
each room
I
live
can't remember the name.
in the live tab, so just tell them good.
Yeah, a little audio echo.
I live in Black Dog. These are the four Linux Tech.
We'll turn this off just when we get it started.
Well, you heard me talking about Linux checks, right? Which doesn't, it's not really a very
I know.
there are lots of.
How's the day gone so far for everybody?
We got a real neat group of faculty over there. There's a lot of them in the world, like one, our number one, Kevin Blackwell. He was running all the computers, 200-some computers on campus, but he had 13 kids.
I muted it.
And he needed more money, so he was juggling 78 external accounts, like medical. He'd come in on a weekend, set it up, and Monday morning it would be flying. So anyway, we got good people over there.
Yeah, I never had a job in town. I do almost all volunteer work, so it's all been
Right on.
volunteer for.
Yeah, I've been trying to get some sessions. I just saw the last hour. The one I was watching really popped in here on First Black Engineers. Really good piece. I'm starting the rest of that. I got the phone mobile. They're recorded, so I'm looking forward to seeing the recordings later.
And where did we go? Because one of our guys couldn't make it, and Is it right at the website, the Access Northwest, how they can go watch
Yes.
some of these?
Yes, it is. It will be under Join Work Adventure. So it's right when you open the page. It's like the second button you can press.
Great. Well, thank you so much.
No problem.
On their computers.
Oh, I can
Fair enough.
Yeah, actually, if you scroll to the right.
Right,
it's a little
better.
bit- Thank you.
You can introduce him at 10.
Nice to see people coming up, you know?
Or you can use this session.
What are you guys studying?
Computer science. And they go and get like chargers.
That's awesome.
Oh, you're fine. I'll hang out.
I don't do anything for this one.
No, yeah, we should, everything looks like it should be good there.
The only thing that won't catch is the, oh no, it's okay, it is still picking it up, okay. For the audio, if it's not up there at the top.
That's awesome.
Oh, and I can try to set this up to be.
It's dead, it's all AI.
I don't know. Look, I mean, you can like. I think that there's a lot of cool stuff you can do with AI, like use it to iterate real fast, but it's not really a great solution if you want to find something that's novel, like some novel solution, because programming is like a really cool way to find new solutions to problems, because you start programming a solution to something, and then you realize, oh wait, this is actually like really similar to this other thing, and I can like generalize it in this other way, and then you end up with something that you never would have even found in the beginning because you did that process.
It's just that one, but we can disconnect it from here.
We could do, actually, what we could do here.
I mean, you can help. Like, okay, I found this thing, I have all this stuff, I'm organized that way, so put it at the table, sure.
Yeah.
But then you have to check the
If you were to get me one,
spell check.
that's smart too.
You might not know, but you might.
But right now, they're still like having it's like this part one doesn't really have.
That one that we were just in, that was the one, the future fixing technology box theory. Is that one that we were in? Oh, okay. That's right.
You know, like there's like this timeline menu, and there's a whole bunch of like art that's supposed to be there.
It's 60 minutes, and then is it, it's 15 and then 15?
30 minutes is 15 minutes. 15 Q&A.
I thought it was 15. Otherwise, everyone's going straight up to the next point.
Oh, they are?
Otherwise, like.
Because we should have them like an hour apart on the schedule. Let me just make sure.
Right, on this, it's one of those.
I mean, he can go over it, like, because there's no one after him. But I was told 15, 15, and then let them go over in either category and a little bit over at the end if they like.
Llama offline, but I have a story. I want to know more. What else do they do? The maker was like, I think you should put this at the beginning.
That's really cool.
Wow.
Video sampling and then make that
No, Sora. And they deleted their entire. That was Sora. I haven't used any of that. I'm not really into that. More of a security.
I also write posts. I'm always looking for the good titles.
I am. Yeah, I'm more into that.
Get my video guy. I knew if I was going to
Yeah.
get
Oh,
okay. Yeah, I probably got closer to 30 minutes of material, honestly. I thought I had 30 minutes and 10 minutes for Q&A, but we'll make it work. We will make it work.
Let him have 30 minutes.
That's a great way.
Good morning, everyone. Welcome to Linux Fest. Today I'm introducing. You already know. Yes, Dwayne Daniel. He's remote, by the way. He's over there in that corner, right there. For protect humans at all costs. Why technology can't solve security.
Okay. Awesome. Thank you very, very much. I am super excited to be here, even though I'm not physically there. I'm the first virtual presenter of the day, and I understand I'm the last thing between you and lunch, so we'll get going. I highly recommend you grab these slides, and you can do that from that tiny URL you see on the screen, tinyurl.com/Dwayne-LFNW. We'll take you to the slide deck I'm looking at, and then all of the speaker notes have my attributions for pictures, mostly it's Wikimedia Commons, and links to other things. But I got a lot of material, like I say. I somehow thought I had 30 minutes of speaking and 10 minutes of Q&A, but we're going to go through this quick. This is what good security looks like. This is the definition, and I think we all need to believe this is what the goal is. There's no flashing alarms, there's no smoke coming out of a computer somewhere, there's no attacker succeeding. It's people away from their machines doing what they love as people. Because technology should be facilitating this. It should be facilitating the rest of our lives. But unfortunately, I work in low security. I've been here for too long now, and it's just a raging dumpster fire. Let me tell you about one dumpster fire in particular. Not my friend Leslie. She's awesome. She's great. I love my friend Leslie. She's real. The picture is Wikimedia Commons, but she works at an insurance company, and she's an accountant. And she uses technology day in, day out, and she knows it's important to be safe. She knows she's guarding the data of clients and keeping everybody happy. One day she got an email. Looks something like this. This is literally the Wikimedia entry for phishing. And she said, hey, that looks suspicious. This doesn't smell right. But she can't remember what to do. So she asked her boss, said, hey, boss, there are accountants. I don't know what accountants actually do, so I just said there are account boxes on this one. That's the picture I found on Wikimedia. Go public media, go open source. And she said, I don't know what to do with this. And her boss like, I'm busy. I don't remember either. There's probably an email or something. Go check your Slack. Go figure it out. And she spends a while on this, she said. Longer than she meant to. When she realized, like, I can't remember what to do. I'm running out of time. I know. We have a security team. I'll just forward this to security. So she forwards a phishing email to security at her own company. And they come to her desk and yell at her. Literally, people showed up at her desk, physically in the office, and said, why did you forward this phishing email? It's like, well, it's a phishing email. Yeah, here's the policy you're supposed to have followed. You took a 5-minute training on this when you first started, and you clicked that you remembered how to do it last year when we sent an email and asked you to remember. This is on you. And she felt really bad. To me, this is the worst possible outcome of a security situation. Not data gets lost, not machine went down, not we had some downtime. It's that people are being crushed under the weight of you're doing it wrong. When all we want to do is our jobs, and all we want to do is be with our families, play Monopoly, and not be around blaring alarms all the time. I'm Dwayne. I'm here in Chicago, Illinois. I really wish I could be there in person with you, like said, otherwise. But fortunately, this conference let me remote in. This is the first time I'm giving this talk, so if it was a little weird, a little sideways, I lose track a couple points. Apologies, but I'm still tuning it in. But I believe in the message. Go check out my website. You can see where I'm going to be in the world. That's basically all it is. If you want to actually see what I think about, talk about LinkedIn and Blue Sky are better for that. And always feel free to reach out to me. I am happy to talk to you about pretty much anything but technology in general. But I work for a company called GetGuardian. That's the GetGuardian there. We come up with a couple points in this talk, but I'm not here to say GetGuardian. I'm here to talk about this problem that I think is affecting everybody And that's this giant dumpster fire of security. What do we do about it? What are we actually protecting, especially in a world where things are moving as fast as they are? Now, I went and looked and saw if I could find some reliable stats about cybercrime, and they're all over the map. I can't find two websites that agree. So I just grabbed this one from Exploding Topics, said, you know what, that sounds somewhere average for the numbers I'm seeing. There's some crazy number floating around there that cybercrime is like a $15 trillion industry. I don't know if I buy that 15 with the T. Maybe overall in damages, maybe, I don't know. It seems like a lot. That's like the bottom half of the population, country-wise, all their GDPs put together. That's how much money that is. I don't know if I believe that, but I do believe that cyber attacks, we've never had more of them. And while these numbers are all over the map, I do believe CrowdStrike. Love them or hate them, CrowdStrike does great research. And they came out with this report. If you don't read security reports day in, day out, I understand it's a boring life sometimes, but I highly recommend reading this one in the Verizon Data Breach Intelligence Report, the Verizon DBIR. It comes out in a couple months. It's the best thing I think we write in the entire industry. But anyway, the point here is that CrowdStrike said, hey, we've seen an 89% increase in AI-enabled attacks. Guess what? It's 2026. There's not really going to be many attacks that aren't AI-assisted at this point. So we're just seeing overall numbers go up. Also notably here, literally they say notably, 82% of detections were malware free, moving through authorized pathways and trust systems. What that trust system looks like are the authorization gateways, the authorization tokens, the API keys, the password user database names, username, passwords, database URLs that contain the connection string. And in the last year, this has sped up to a horrifying degree. Like I literally struggle with this for the last month, ever since I went to RSA conference and all of this stuff happened with Trivy and Kix. Bitwarden just happened like 2 days ago. These are supply chain attacks that are self-propagating. And the whole point is to steal credential access. Credential access impersonate the developer and the developer's access. Really, the person is what they're coming after now in an indirect way. They're not trying to steal your personal bank information anymore, but they're trying to steal literally all the credentials you have for all your cloud systems, all your build systems. That's what the current state of the world looks like right now. And it's not just through NPM packages. It's not just through PyPy. It's not just through suspicious websites where you clicked a weird link or an phishing email. At this point, we're just turning the corner to agentic systems. If you've deployed OpenClaw or Claude Code or any of the agentic systems on your machine, you are now a target for websites that inject JavaScript locally and say, hey, give me all the stuff. Give me all of your environment variables. I never thought I would say this, and I sound crazy saying it out loud, but local environment variables are no longer safe. That is an exploitable attack surface right now that we are seeing things like Cisco. How did their 300 repos become public? How did Anthropic accidentally leak so much code? No, these are targeted attacks that say you have access to this. Go ahead and spill that out. Some of them more sophisticated than others, like the Axios was North Korea attacking. But so much of this is just propagated. The code tells the computer, do this. The computer just does it because it's a machine. Machines are dumb. The good news is we've never spent more on technology and we've never spent more on security, except this isn't really solving anything. We see year after year after year after year, our budgets go up. We always say we do more with less, but we spend more on cybersecurity year over year. And I'm just looking at the projection here from Forrester. You can go do your own research on like how the last 10 years have rolled out according to them. I'm not going to do more Forrester research for you. But what we do know is there's this dark mirror of like what is wrong. And thank goodness, Open Worldwide Application Security Project exists. I'm an OWASP member for life. I love OWASP. They do great work. But the OWASP top 10 list here's the big 10 we're getting wrong right now in cybersecurity. And we've had this for a long time. And if you look at it close enough, we rearrange some stuff, we relabel some stuff, we regroup some stuff. But we've been doing the same general bad
outcomes for security because we keep trying to fix the machine. We keep trying to improve the technology itself in kind of an isolation. And we really do. But you know what? There's vendors out there that can save you, right? Notice the date on this. This has been a joke for as long as I have been in the DevRel space. Actually, this is I started being a developer advocate back in 2014, and 2017 this joke comes out. But if you've never seen the cybersecurity landscape, go just Google that real quick, or write that down for later. It's horrifying. It's an eyesore. Like it's a little fuzzy on here, but trust me, the current one is you can't see it. You can like see it from space. You'd have to blow up everything that big to like it's just ridiculous number of vendors. And every vendor thinks they can solve a thing. I work for a vendor after all. We all think we can solve your thing. But that thing that you're trying to solve that you need to solve, you understand that doesn't exist in isolation. And a lot of tools say, I'm going to solve this thing for you if you do it our way, if you do it in isolation. You know what? It could, but you're gonna have to get humans to do it exactly the right way every time. And the one thing, man, we know for sure is humans don't do it the right way every time. I mentioned the Verizon DBIR earlier, the Data Breach Investigation Report. Highly recommend reading it, but their numbers year over year over year, it's always like 70 to 90% of breaches involve a human element, meaning someone got tricked, someone let their guard down, someone accidentally clicked. Like so many of these supply chain attacks now are literally we're going to fish the maintainer of a giant project that gets 100 million downloads a month. Click the wrong thing one time and suddenly npm test like some basic low level npm packages got owned. It's humans. End of the day, this is what we need to protect is the human being. Because just trying to protect the machines, just trying to apply technological patches to this problem set has resulted in the giant dumpster fire we're living in of constant attacks, nonstop cybersecurity news. And it's depressing. I'll be honest with you. Like I talk about this stuff a lot and it affects me and I'm dealing with it myself. But I think there is a positive way we can approach this. And that's the last part of my talk. That's the last half of my talk. I'm speeding up a little bit because I just want to make sure everybody gets to lunch on time. But what do we do? What should we do? Who do we supposed to protect? Turns out each other. And that sounds overly simplistic, but what is a company? A company is a group of people working toward a similar goal. The goal of your company ultimately is to make enough money to pay all the employees and the investors and the people. How you do that is awesome and cool. Whatever you're building, whatever really cool thing you built, that's great. Keep building that thing. But understand, you're not building in isolation. This is really, really important, especially here in 2026. And as we move forward, as we move to a world where everyone's getting pushed to go build your own agentic army, go manage this fleet of coworkers that you have coordinated and multi-agent systems like Claude Code and Claude Cowork. We're getting pushed farther and farther apart. And this is not just isolated to tech, not just the security world, not just the development world. This is everything. We're being pushed farther and farther down this path of isolation to work as a silo yourself to produce value, whatever that is. The ultimate value, though, is the people around you. That's your ultimate greatest resource. And we have been doing it for so long, making people feel like they're the problem. When ultimately, the way we built the systems and the way we architected certain things and the way that we saw it as you got to be smarter than you are, somewhere along the way, we lost our way. We've lost the path. We've lost the thread because we can't keep up with AI. I don't know if you're staying up to date on the Mythos, Anthropic. You know that would come up eventually in one of these talks. Yeah, we're never going to beat the machine. The machine's faster, has bigger context window, and can find bugs. For $20,000 in tokens, it would take a research team $1 million in like a month to even try to find. What are we protecting? Ultimately, all this is leading to burnout at a way that if we see it from this angle, I think we can treat it a little bit better. I think we can view it from a little bit more healthy perspective. But stepping back and realize like, no, everything that I'm describing, why I'm so anxious and like pessimistic sounding is because I, just like most of the industry, am experiencing some level of burnout. I'm being completely open and honest with you here today at the end of April 2026. I'm exhausted. I feel demoralized by what's going on constantly. I don't know how much good I can do in the world. The fact I can show up here and give a talk and hopefully inspire some of you to go back to your teams and have a better set of conversations and better outcomes in the long run, that is my hope here. Because if you're anything like me, if you're anything like 84% of people in security, you're feeling it. Over the lifetime, most developers burn out. And this comes from pushing you farther and faster than you've ever had to work before to do technical feats that are crazy. At the same time, security's over here saying the world's on fire and you're doing it wrong. And we're starting to yell at each other at a level that I don't think is healthy. Not starting to. We've been doing that for a while. But this is just some of the research I did. I think I'll link to this in the show notes where I got some of this research. But happy to publish bibliography if you reach out to me. I have those notes. I'm happy to share. And this burnout directly affects bad outcomes. Now, if there was a magic wand, I could say you could go back to your office on Monday and wave a magic wand, and suddenly everyone you work with would suddenly get cured of burnout. I would sell that. I'd be a billionaire. Life would be great for everyone. So what do we do about this situation where the burnout's very real, while at the same time we've never done more stuff? Do you realize how fast GitHub itself has grown? Like, I read a lot of reports. So the state of the Octoverse last year shook me a bit. That we're pushing so much more code than we even did a year ago. 1 million more average closed issues per month. 1 million projects, or 1 million across all the projects. There was almost 2 billion commits last year on GitHub. Record numbers. We've never seen it this high. Part of the reason why is because it's no longer just humans doing it. It's humans conducting these orchestrations like Claude Code. Now, GitGuardian put out this free report every year. Download it through Tor. We do not want your email address. I mean, we like it, but we're not going to ask for it. And we put out all the research we do. We look at every new commit that hits GitHub public, and we scan it for a secret. If it's got a secret, we email the committer right then and there. It's our Good Samaritan program. We ask nothing in return for that. We ask you to please don't commit your secrets in public. That's dangerous for everyone. So please don't do that. But other than that, we're not going to ask anything else of you on that initial email. If you write us back and say, hey, let me more about your project, or click the links, of course, we're happy to work with you. Anyway, as part of this research, we noticed a bunch of other stuff, and it's all in the report. But this is the one that stands out to me. The quick, dirty version is if you use Claude Code to commit your code last year and let it go ahead and co-author the commit, you were more than twice as likely to commit a hard-coded secret. This is not a talk about hard-coded secrets. This is just one data point, but credential abuse is the number one reason attacks are winning right now. So this is the top concern in my world of, do we still use hard-coded credentials? Can we use API keys that are ever legible in plain text? I think the answer is no, but that's not the point of today's talk. The fact is, but my point is that we are working independent, isolated, faster than ever before, pushing more code ever before. And the results are, we are making more mistakes faster than ever. There's a report from CodeRabbit. I didn't put it in this talk. I really wish I should have now. That shows like you're 1.7 times more likely to make a basic programming error by doing a code at this rate with as AI assistance. We know for a fact that you're more likely to commit secrets, and you're like 2.7% more likely overall to make a security issue or cause a security issue by doing all of your code through Claude Code. That's from CodeRabbit. That's from last year. Take it with a grain of salt. But the point is, we're doing more and more and more and more faster. But we're the same company. The same company that 10 years ago was successful, that you joined, that had a growing economy and a growing sales footprint, a growing customer base. Everybody was getting along and you were working. That's the same company you work for now. The world feels like it's on fire, but as long as you have each other, this is what I tell everyone in Chicago. Like, I ain't worried about Chicago. The world can fall apart. Bigger picture, like, bad things gonna happen. But man, we got each other. We got the city. We got each other's back. We got the Cubs. We got the Bears. We got each other. And if we all like come together and start seeing each other not as you are that department over there, you are that role, and we start treating each other as people better, I think we're gonna have better outcomes. So I want to be positive for the rest of this talk. I was very negative for the first 2/3 of here. So what do we do? And I'll be quick because I understand it's supposed to be 15 and 15, but I got another 5-7 minutes and then I'll open up for questions. So what do we do? I think any good plan looks like this. It's a counterclockwise virtuous cycle. The first part is raising awareness. Congratulations, you are already part of this virtuous cycle. You are already listening to me talk today. You are already willing to at least raise awareness in your brain, and that's going to help. Now go raise it in someone else's brain. Go have this conversation. Hey, we need to get better at all of this. How are you doing? Like, let's connect. And start raising awareness that needs to happen. And create some clear processes around what you want to do, no matter what that is. And finally, there will be a point where you say, it'd be helpful to have a tool that helped us do this. You might already have it in-house. I'm not here to sell you tools. I'm here to sell you the idea that you can use tools to then turn around and raise more awareness and train people on better processes to use those tools to follow the processes that you document better, that you improve through the virtuous cycle of iteration. And if that sounds like DevOps to you, yes, this is the heart and soul of DevOps. Let's figure out what to do. Let's do it collectively, figure out how we're going to do it as a unit, as a team, as a company, as an organization. And then we'll figure out how to automate it once we figure that out. I think right now we're really stuck on use AI, automate the thing. And I think a lot of people are, but automate what? I'm doing everything as fast as I can. If I could automate it faster with N8N, I would have. Everybody wants exactly the same thing. They want to go home to their families and have a good life. I'm thoroughly convinced of this. I don't care what your belief structure is outside of that. I think that's the one thing we all have. We all, at the end of the workday, want to be with people that know us as us. We let our guard down a little bit in our trust zone and do our thing. Now, how we all try to get there is all going to be seen through the complete lens of who we are. But in the work environment specifically, we see ourselves through the lens of what we do. And I'm challenging everyone here that the first thing we have to do, I got 3 practical suggestions, and I'm gonna wrap it up, of what we do with this information. If you want to get out of this burnout cycle, if we want to get out of this security just isn't working, security's failed us. I've heard 3 CISOs in the last year say that out loud, including a CISO, a former CISO who wrote the first iteration of OWASP top 10 list. Said, yeah, security's failed. Same problems. We haven't solved anything. This is how we think we solve it. I'm not the only person that thinks this. I'm just the one saying it out loud today. First, we need to connect with your colleagues as people. And this is a real challenge, but I'm going to challenge you to do it. Reach out to someone you haven't talked to at your company, someone outside of your team that you're aware of, and ask them if they got a few minutes to talk. It's going to freak them out. If you've never talked to security, hey, you got 5 minutes to talk? I don't know what you really do here, but you know what? I don't really know you. Just start having that conversation. Hey, if you're in the same office, you're in the same physical place, use that advantage. Everybody likes candy. Everybody likes coffee. Well, not everybody, but figure out what they like. Buy them a cup of coffee. Buy them a donut. You show up to the security den, you show up to the SOC with a giant 2 boxes of Krispy Kreme or whatever donuts you got in your area, they're not going to be mad at you. They're going to be mad if you show up to the SOC and you have your hair on fire and you think the world's burning down and you really need their help. But if you show up and like, hey, you guys are doing awesome. Like, what's up? And have that conversation. If we don't build the empathy, then what are we doing? You might as well just go devote the rest of your life to Claude and just making tokens so Anthropic can have more money and just build stuff in isolation faster than you thought you could ever before. Who's going to use it? Who knows? Because not a human's going to use it because you didn't build it for a human. You built it for automation's sake. We have to build with empathy first. But once we do that, and this goes from the development side out and from the security side toward development, we have to design for reality. We have to be realistic, and we have to have that conversation of, wow, that looks really good on paper. How does that work? How does that actually work? What's going to look like in operation 6 months from now? Because people are going to do what they're going to do. They're going to do whatever that is, no matter what your policies say. So if you're a security person thinking, how am I going to better work with my team? Go figure out what they actually do and don't fight them on it. Go look at the reality they live in and say, yeah, we can secure that. Hey, that thing you're doing, that database you're getting to, there's a much safer way to get there. I see why you're doing it that way, but there's a safer way. And if you're a engineer, a developer, and security comes to you with like, here's a giant pile of you musts, push back. It's like, that ain't how this works. Like, at the end of the day, we're a company. We're accepting risk. We have to be here together. Let's figure this out. Because if you just try to put up gates to anything, people are going to go around those gates. That's just how it works. We have to make the easiest path the safest path. We have to make the thing that people are willing to do the overall better option. And how do we align that reality? There's no magic solution here. But I can tell you, if you do this over a fence at each other without talking to each other, without having empathy, without being able to say, Anna, my coworker, what's up with this? Like, what do you really feel on this? Like, if you can't have that level of conversation, you're just going to throw more tech at it, and it's going to keep exacerbating the situation. Part of that is understanding where friction points are. Part of that conversation needs to be, how can we make each other's lives better? Because development wants to go as fast as possible, always will, always does. And security knows at the end of the day, slow and steady is going to win the race, but wow, it's slow and steady. And there's a lot of tests. There's a lot of false positives. But at the end of the day, we actually do speak the same language if you can speak Git. Not the protocols, not understanding porcine and plumbing, and you understand all like the transaction levels and whatnot. But we use Git. We have this magical ability inside of Git called Git hooks. And I challenge everyone that if you've never written a Git hook, go write them. They're super handy. You can do anything because it's just, if there's a file with that name and you cross a certain threshold, it does whatever's in that script. Now, why this is important is you can put pretty much any CLI security tool in there. So, hey, you want to make a commit? Pre-commit hook's my favorite. Let's make sure this is safe. And if it's not, you have this magical ability there and to say, what's the easiest thing that's going to make their life better, not disrupt their workflow, but at the end of the day, get everybody what they want. And I know this because it works, because pre-commit hooks for secret scanning work. Pre-commit hooks for, I guess they're not pre-commit hooks, but hooks into AI agents work the same general way. It's not Git based, but the same idea that there's these hooks. But Git hooks are so well established. There's so much writing about there. There's so many examples. I tell everyone to start here. And then you'll realize, wait a minute, I can hook into, and let's put guardrails, not gates. And lastly, if you don't have a security champion program, this is a really good conversation to sit down and have with management, to have with security team, to have with your development teams, and get together. This is really hard to do with no empathy. This is really hard to do as a carrot or with a stick method. This is a carrot method. But people on your teams are going to want, some people on the teams are always going to want to say, yeah, why aren't we doing this a safe way? What, is there a better way to do this? As soon as someone's willing to raise their hand and say, yeah, I will be your liaison, I will be that communication and conduit back and forth between security and development, and vice versa. You'll be the security person that's like, I am really interested in this project. I would love to understand how we work with databases a little bit better. I'd really love to understand our ORM a little bit better. This works both ways. It can make security champions and make development champions. There's a great talk from Dustin Lair. He runs a company called Catalyst these days. They can give, if you want metrics on like how to metricize a program, but there's many examples of this out in the world. Like We Hack Purple has a great blog post series that spells this out. And of course, our friend over at OWASP built you a guide. I had given an entire other talk about these top 10 principles. And it's for building one of these, but it's all about empathy. Because at the end of the day, if all we're going to try to do is throw more tech at the problem, we already know how that ends up. It's a giant dumpster fire. We live it every day of our lives. We got to step back and think about what are we actually doing here? And I think the answer, if it's not, we're protecting people. If it's we're protecting data, Jason E. Street famously said once, you can't pay an employee enough to care about your personal data. You can't. That's an impossibility. You can pay them enough to pretend, but they're never going to actually care. Can you pay someone enough to care about you? I don't know if that's true. Can you talk to someone and empathize with them, and then you can make a connection, and then you suddenly care about each other? Yes, we've been doing that for thousands of years. That is the heart and soul of what humanity is. And empathy is that thing. So let's collaborate with empathy in mind. How can we make each other's lives better? Not safer, better. And if we see all of security as a human-centered event, as a human-centered goal, we're going to end up doing a lot better overall. And we'll, by the way, we will get to better security for our servers, for our data, for the code. But that's not the end goal. The end goal is to go play Monopoly with your families. But man, I wish I was there with you right now today, because I'd go eat lunch with you and love to have some follow-up conversations. But I'm Dwayne. I live in Chicago. Check me out online. I'm happy to, if you want to email me directly and let's start a conversation right now, I'll be online for the next couple hours. Happy to stay in touch with you. So thank you very, very much. That just goes to our blog, getguardian.com/blog. That's the quick plug. Just go read our blogs, and it'll, like, if you like what we do, you like what we do. And I highly recommend getting these slides because of all the links in it. And if you have any questions, I know I went way past when I was supposed to have just stopped talking, but again, I apologize. I thought I had 30 minutes. Yeah, I'm happy to stay. I know I'm between you and lunch, but I'm happy to stay on as long as anybody wants to talk. I'd love for you to turn the camera on though, so I can see if there's anybody in the room. Oh wow. You can never tell at virtual events. You can just never tell. Thank you all so much for having me. It's a honor, great honor to be part of Linux Fest Northwest. Yeah, I'll put this back up. So looks like we're having connection difficulties. You're frozen on that end, and I can't hear anything. Oh, there's a chat. I got it. Okay, one question being formulated. All right, I got a green light. Oh yeah. I wasn't meaning to pick on Claude Code. I'll go back to that slide from the report. Yeah, we're not picking on saying one's better than the other. I don't have the slide pulled up. I could pull it up, but it's part of the report. We didn't just look at Claude Code, but that was the one we had the clearest signal from because of the co-authoring. And it was a signal that our researchers said we have the clearest signal from Claude Code. But I know it's very uncouth to do this, but the state of Cedar Sprawl report, like I say, it's not behind anything gated. Claude. Somewhere in here. Yeah, here we go. Claude Code, Lovable, and Cursor, the three that we actually did the study on. But it's the same thing. If you are, so I didn't really explain that well because pressed for time. So you can watch over the course of the year, the commits containing secrets spikes up in August and then starts ebbing back off by the end of the year. So that's how we get to that across the year, like 2.4x more likely to leak a secret. Gemini is just another way to do this. But we think that the problem isn't that the code assistant is making these big mistakes. It's ultimately the humans are checking it in. And if you're just letting Claude Code do the whole process, it's less likely you're doing reviews when you're producing 4x the amounts of lines of code. We're inferring that that's what's happening based on anecdotal evidence and some conversations we've had. Let's see. Are there serious coders use Gemini? Was the clarification? Yeah, I know a handful. I don't know a lot. I think personally, I am using Cursor these days, and I've been using Copilot since that first initial like beta that they came out with. I bounce back and forth. It depends on the project. I like Cursor for front end stuff. I don't know why. I just do. I think it does CSS really well. Don't that's a personal experience, and your mileage is definitely going to vary. But I've never used Gemini personally for anything that I've ever, other than just messing around to test it. But don't know. If you have good results on it, let me know. Like if you have good data that never leaks a secret, please, 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 we'd love to see that research. All right. Well, thank you very much. Well, enjoy lunch. Enjoy the rest of your day. Enjoy the rest of Linux Fest Northwest. Oh, okay. I'm happy to stick around.
Okay, is that?
Oh, I can hear you. I can hear you now. You don't sound like you're in the end of the tunnel. No.
Oh yes, he can hear us. Okay,
it's fine now.
So a lot of what you're talking about seems kind of reminiscent of like the era before we needed like security. You know, like prehistoric, like pre-computers, like like what we call modern society. You know, like we didn't. I mean, none of us were around then, but I mean, you can reason that they.
Oh no!
Because they
now
have such a small.
I've lost audio.
And I can't hear you, by the way.
Yeah,
so if it sounds like I'm talking over you, that's it. But it seems like what you're talking about is very analogous to that, and I really liked the. Oh, he said he lost audio.
Back now.
Gotta feed my kid.
Keep going.
Yeah, and it just seemed very analogous of that, and I thought that was very cool. And I just wanted to throw that out there and see if you have anything to branch off on that.
Thank you for that. You're not. I hadn't thought that really coming in, but what is security then today other than just people? And you're right. We've needed that since the very, very beginning. I hadn't really thought of that because I think back to the beginning of time. I go back to UNIVAC and ENIAC and the big artillery machine calculators that we built in World War II. And I always say that that's the beginning of modern cybersecurity because how you protected those machines was you put someone in front of the door with a gun and you put a lock on the door. And that was how you protected the stuff. And it wasn't until we had like 12 or 15 computers hooked up together that we realized like we needed to keep track of like who's doing what where. And then we invented passwords. Like Berkeley invented password systems. Fun fact, Stephen Bourne, the guy who wrote SH, the thing that became like was rewritten as Bash. His password on Berkeley Linux was Bourne, Bourne. That true fact. That was how good it was for security back then. But at the end of the day, that's all it was. It was like we need to help the people that need to use this computer do their job safely. We need to help the people that run these computers be able to do that and not have all of the bandwidth, literally all the bandwidth in the world taken up by kids trying to transfer Zork across the wire. So how do you do that? Well, you put security measures in place. But that's how I see like old school security. But at the end of the day, you're right. This goes back to the Stone Ages. This goes back to the first time we locked up food. If you ever read My Ishmael, it's a really good book. Peter, is he Peter Quinn or Quentin? I can't remember who wrote it, but it's called Ishmael. It's three in the book series. The story of B, Ishmael, and My Ishmael, and it's a story of like how modern society evolved from there. So anyway, I see your note. We got to wrap it up. Thank you so much. Pleasure to be here. Feel free to reach out to me on LinkedIn. Reach out to me anywhere else on the internet, and I'm happy to keep the conversation flowing.
This is still true that without physical security, all other forces
What is this Red Hat thing?
You should watch. I don't really know anymore.
Tough question.
A wholly owned subsidiary of IBM.
Oh, but you're still red.
As it happens. We are still Red Hat.
Still red for that.
Yes.
When you see the slides go purple, then
Yeah.
start panicking.
Could be blue. Could be blue.
Blue's okay. Blue's Fedora.
Yeah.
Yeah. Blue's good.
One more minute until we get started here.
How does this relate to Myth TV?
It does not anymore. But
That's the only reason he was here. He's leaving.
this is my first time back at Linux Fest Northwest since presenting about Myth TV over 20 years ago, I think. I actually, was big into Myth TV. Anyone doesn't know, Myth TV was basically a TiVo work-alike thing that ran on Linux, still does. And I got very involved with it and running Myth TV on Fedora long ago, and my work maintaining a how to run Myth TV on Fedora guide and helping in the community actually sort of led to me getting a job at Red Hat.
That's very cool.
Which took me from the Pacific Northwest to Westford, Massachusetts. And I am still working for Red Hat over 20 years later. But I moved back because I could. Yeah.
Is your text-to-speech engine, is that like Whisper?
That is not me, that is the conference.
Cool.
Yeah, I don't know what that is. We are right at time, so I suppose we should formally get started. So, welcome everybody. My name is Jared Wilson. I am a senior principal software engineer at Red Hat. As I said, I have been there over 20 years now. I am the kernel workflow team lead, and today we are going to talk about Red Hat Enterprise Linux / CentOS Stream kernel backport automation, which is a big part of my day job these days. So, first off, there's a bit of a problem that started all this. CVEs, common vulnerabilities and exposures. Back in February of 2024, the Linux kernel project became the Linux Kernel CVE Numbering Authority, or CNA. And because of the way that the Linux kernel project decided to handle CVE numbering, the number of kernel CVEs has skyrocketed. Basically, anything that goes into a stable kernel is a CVE now. So Red Hat customers expect CVE fixes and mitigations, and some of them have service level agreements with delivery required within X number of days depending on the severity of the CVE. Red Hat did not get an increase in kernel developers commensurate with the increase in the number of kernel CVEs that were suddenly being churned out. So we got slammed with hundreds of new CVEs, and it wasn't just new stuff either. It went retroactive to the past few years of fixes. So we've got hundreds of new CVEs that we now need to scramble and take care of. And the solution, of course, automation. Don't manually do things that can be done by robots. Little asterisks. This does not necessarily mean AI. And in fact, most of this is not AI-based. It is structured, mechanical. It doesn't have, it's all deterministic. It doesn't go haywire most of the time. So we do things like assignment of the work to the right team, identification of the patch fixing the CVE, backport of the fix, submission of a merge request containing the fix, validation of the merge request, and testing of the fix, at least a first level smoke test of the fix. Some architecture notes on this that will be important for some of the upcoming slides. Most of this kernel workflow infrastructure is written in Python. Most of the code operates in Red Hat OpenShift hosted Podman containers. Most of the code is 100% open source and publicly available. Links at the end of the slides here, albeit highly tailored to Red Hat's needs. The containers are in fact Fedora based. They are currently actually Fedora 42 based, which is a bit problematic. we've got just under a month until it goes out of support, technically. That is actually one of the things that I've been working on the past week or two, is updating our containers to a later release. So what does this workflow look like? We've got a couple of boxes here that sort of depict the overall workflow. First up, there is the identification of the CVE. It is announced upstream via Linux CVE announce mailing list, and it is logged and committed in the Vulns Git repo. Both of these, you can subscribe to the Linux CVE announce mailing list on kernel.org if you want to. You can clone the Vulns Git repo. So the information shows up there first. In 99% of cases. There's also an embargoed CVE case, but we're not worried with that here. So that happens upstream first in this first box. Second box, we've got bug creation. Red Hat has a product security team that tracks the mailing list and says, we've got all these CVEs that we need to file issues for. So they go and file JIRA issues. We use JIRA these days.
Have you thought about ServiceNow?
We also have ServiceNow. Okay.
We've got all of it. SharePoint.
And I don't want to. No. Let's not get into that. Okay. So anyway, product security creates these JIRA issues, and then there are some automatic bug updates that happen. The kernel workflow team, my team, has this CVE assigner that automatically reacts to the JIRA events and updates the JIRA issues with some metadata. And then after those metadata updates are made by the assigner, there's actually a backporter that then says, oh, hey, I know what to do with this now. And it tries to backport the code that has been identified by the updater. And if it is successful backporting, then it will submit a merge request. On merge request submission, so we're up to step 5 here, there is a message left in JIRA that tells the merge request assignee, hey, I created a merge request for you. Go take a look at it. Make sure it's sane. Make sure I didn't do something crazy. So if it is actually sane, the bug assignee will then mark the GitLab merge request as ready and on with the review process. Or they can fix it up if the backporter did something horrendously wrong, or there's a follow-up fix that's needed, etc. Once that is marked as ready, then it goes into review and testing. We've got developers, we've got minimum review, peer review requirements on all merge requests, and QE pre-verification testing required. And once it's been through that, the merge request is marked as ready, and then we have another automation step where ready merge requests are automatically bundled together into a draft merge request build that is then pushed through the build system and goes through another set of testing. All right, and each of these are friendly with some friendly color coding. The gray pieces are entirely manual and external for the most part. The yellow is automation owned by other teams. The product security team does have a bunch of automation tools to automatically file all the bug issues. The green bits are the pieces that are automated, and most of what we'll cover here today is 3, 4, and 5. And then 7 is the red area here is areas begging for automation assistance. We can do better there, hopefully. And sorry.
In your number 1 presentation, you mentioned a vulnerability Git repo. Is that what backs the Red Hat errata vulnerability list, or is that a separate?
No, it is entirely separate. It's entirely maintained by the upstream Linux kernel community. It does ultimately get fed into. It's more the stuff that happens in step 2 that backs Red Hat's. They ingest the upstream information and then put it into their own system that then backs all of the Red Hat product pages and vulnerability information.
Thank you.
Mm-hmm. All right, so kind of already been through some of this, but here's a real quick overview of what's sent to Linux CVE announce and vulns.git. There is an email that contains the CVE number. It contains the impacted source files. It contains the upstream commit ID of the fix, and our initial deployment of these tools, we actually parsed that mbox file, which was horrendous. Then vulns.git repo came into being, and we used that instead. That is much more user-friendly. It's basically just a tree of files with some JSON files in them that you can more easily parse. So we can extract all the information that we need to know about the files affected, the CVE number, the commit hash, all out of JSON here. And then we have our own things that we maintain. We have a CentOS Stream kernel documentation project that we maintain publicly. Anyone can go and clone it, look at it, submit merge requests if you want to. One of the files in there that is very key to all this is this owners.yaml file, which is basically a listing of all the subsystems that we have within the kernel and who within Red Hat is responsible for maintaining the code that comprises those subsystems. And then included in that, there's a listing of the paths that are basically regex. There's includes and excludes for files that comprise that subsystem. So we can do some regex matching and come up with clever ways to say, okay, this vulnerability touches these files. That maps to these owners. So that's how we determine, hey, assign this bug, this CVE to this team or this person. It is, again, very deterministic and mechanical and no AI and hallucinations involved. There's human hallucinations. There are those sometimes, and you do have the issue of
it goes stale.
It gets stale, and somebody just left the company and we forgot to update something, or 400 people just left the company of not their own choosing. Just example, it could happen, is all I'm saying.
So the this Linux, this kernel vulnerability, CVN, this is the only source for Linux kernel related vulnerabilities?
It is now, yes.
So NVD or MITRE, they will not ever generate a CVE relating to the kernel?
They do not, no. They will take the data from the Linux kernel, I think it's the Linux Kernel Foundation is the official entity that is the Linux kernel CNA now.
And they have some system so they don't generate like colliding CVE numbers or something?
Yes. It's largely all in the files that are in that Git repo for the most part. So they just keep incrementing as they add new things. They also do this is proposed as a CVE and it will get assigned a CVE number and may or may not actually turn out to be a CVE. So they may drop things, promote things.
But when you get that email, is there always a fix associated with the CVE?
In these cases, yes. Because they do not assign a CVE number until it is a patch that goes into a stable tree.
Right.
So there is an upstream mainline Linux.git commit for it already in existence. So you always have that mapping. It is always there. The only case where you don't have a commit already would never be announced on this mailing list.
Don't forget, this
because
is
it's
all the public stuff.
Yeah.
The embargo stuff does not.
Embargoed stuff is handled back channel. You have to be in the cool kids group that's read in on the CVE, and somebody talks to you privately and says, "Hey, we're working on this fix." You know, for things like Spectre Meltdown, those fixes would not have been on here. The people actually working on it would be communicating privately somewhere.
Can you get a number assigned for when a fix is under embargo?
It does eventually, yes.
But not early on.
As early as possible.
As early as possible without disclosing anything.
Yeah.
Okay.
Yes. I'm very, very cautious about not giving anything away. Most of the stuff these days, it tends to become public fairly quickly, though. I haven't seen a whole lot of embargoed issues anytime recently. It used to be something that we had to worry about a fair amount, but they're few and far between these days. Okay, we do have somewhat limited time, so we got to rush through some of these. There's 24 or so slides. Okay, so product security creates a CVE vulnerability JIRA issue. creates these issues. The owners.yaml entry has this Jira component field and the files here. In the issue itself, the component gets set to the same thing that was found in the file. And this commit hashes bit was discovered from the bones.get JSON file. It's dropped into this commit hashes field in Jira. Then the backport tooling reacts to the Jira event that was created by the CVE assigner and says, oh, I know what to do with that. There's some checks that are done to make sure it hasn't already run on this issue. And if everything looks good, it will actually try to take that commit hash and does some sanity checks to make sure this is actually a commit hash, for one, data injection attacks, whatever, etc. And make sure that it's actually a commit hash that we... Uh-oh. We have disappeared. It tries to make sure the commit exists. We'll continue without the slides for a moment. And if it does, it will try to just basically do a dumb cherry pick onto the right target branch. There's some additional bits that are in Jira. The product security team files one Jira for every release stream that we have. And we have some stuff that maps the Jira fix version field to a specific branch in each of our Git projects. So it will always end up in the right place and open our merge request against the right project on a successful cherry pick. So the successful cherry pick, send up a draft merge request. The successful merge request creation results in a label on the Jira issue and a note in the Jira issue to the assignee. Hey, go look at this.
And is that the first time a human would look at the fix in your process?
Correct. So the merge request is created in a draft state so that we don't do all of the processing on it yet, and so that a human can get involved. Because there was a lot of, oh God, what the heck, sort of resistance to this at first. Like, oh God, this is going to be terrible, what are you doing? In practice, it has actually turned out very well. And if you look at a recent kernel RPM changelog for any Red Hat kernels, you will see that the CKI KWF bot user has been very, very busy committing stuff or getting credit for commits in the Red Hat kernels. We have a ton of stuff that actually goes in under this account now that was all automated backports. But yes, we get a human involved at this point just to sanity check things and make sure that there were no hallucinations. Or there is the occasional case where, that cherry pick did something weird or was incomplete, or you need a follow-up fix. Although a lot of the time, usually the follow-up fix is something that we catch ourselves with other automation that we have that calls out this upstream fix. This upstream patch also has an upstream fix subsequent to it that we also need to pull in. But that does currently, it's one of those enhancement things we still need to do. That does currently still involve somebody actually adding the fix to the merge request manually, or going back and editing Jira and making changes there to cause the bot to push an update to the merge request, which it can also do. So it can actually push a V2 of the merge request. But yeah, there's also times where the cherry pick just fails. This is another place we're looking at possible enhancements. There are things like this AI thing that can sometimes do a little bit better than just a straight cherry pick and can occasionally get it right and maybe massage things correctly for code drift and actually apply the change and submit a merge request that will at least compile and test. But it will still be a draft and still needs human eyeballs to look at it and say, yeah, that was actually correct. I'm saying this is actually correct. I'm the responsible party for this merge request, and I'm going to now tell other developers to go review this as well. Okay.
What's your failure rate on the cherry pick?
I think the latest numbers, it's a little higher than that, a decent amount higher than that, I guess. I think we're at about, I think last I looked was around 72% success rate on most of these. It depends quite a bit on which kernel stream.
Old, right? So.
Yeah, so if it's a if it's rel 7 kernel that you're trying to cherry pick a backport into, chances are a failure are a hell of a lot higher than if it was a rel 10 kernel. Because rel 7 is, I don't even know what that kernel base is anymore. But yeah, it's old. I mean, it was released, I don't even know how many years ago now. I've lost track. Rel 4 wasn't released yet when I joined the company. Rel 3 was still current. Yeah, so it varies. The more recent the release is, the more likely.
Rel 10, you probably have a much higher success rate.
Correct.
Currently, you're cherry picking than 8, right?
There's also been some changes for a number of teams in the way they've approached backports over the years. Some of this has to do with our moving to GitLab in the first place. Is we've become a lot more scalable in what we can actually manage to backport. So there were teams in the past that would only, like, we're only going to grab these select fixes or features because that's all we have the bandwidth for. And now there are more teams that basically take, if you look at a rel 10 kernel or even a rel 9 kernel right now, the number of subsystems that are actually very close to upstream kernel 7.0 is scary. The delta there is not as big as you might think. So in those cases, the cherry picks are also a lot more successful because the code in every subsystem, a lot of the subsystems, actually matches upstream very closely. So there's very little drift. But yeah, some of the backport tooling, AI backport tooling we've been working on actually directly ingests our historical backport work for RHEL to use as a training corpus to learn how do I properly backport to RHEL. So we're looking at incorporating some of those. They're in use by a number of people within the company for when they are personally doing a backport, but we are looking to tie them in an automated way on these on the failed cherry picks essentially to boost that 72% up a couple more percentage points. Don't know. We'll see how far it'll get us there.
So do you mean that? Sorry.
So do you have a secondary tool then that checks like for kernel ABI changes or?
Yes, we do. Some of that we'll hopefully get to. 10 minutes later. Okay.
We have about 15 minutes.
Okay. So here's a quick overview of what this automated merge request looks like. Although this is an old slide and it has my name down here instead of the CKI backport bot. But it nowadays has the CKI backport bot's name down there and was opened by that account. These guys here are a bunch of labels that are specific to different webhooks that we have that run over the merge request and do things like check. I think this is actually old enough that it doesn't have the kernel ABI stability check on it. But one of them is actually, does this change break kernel ABI? There's do we have like here for commit refs? Do we have existing? Do we have references to upstream commits all present? Because we try to have all of our backports reference one-to-one to an upstream commit. We try to have as little that is not upstream as possible. A couple of other ones. We'll hopefully get into those. Oh, but wait, there's more. So. Only the initial assignment, issue assignment, and commit hash identification tool is actually strictly tied to CVE work. The automated backport tooling will actually react to any JIRA issue in our system that has the commit hashes field populated and has all a variety of other fields that are set to the proper things and such. And several teams within Red Hat have actually figured this out quite a while ago. And we've more broadly announced it, but quite a few teams actually use this themselves and just go into their JIRA issues and say, okay, well, we need to do this fix, that's this commit hash. And they will just put the commit hash into their JIRA issue themselves, and the bot will happily spit out a backport for that as well. Basically saves them the trouble of having to go, okay, find the right kernel tree in my local machine. Okay, update it. Okay, get cherry pick. Yep. Okay, looks good. Okay, now submit a merge request and all that. Just saves a lot of busy work from developers. So they are loving that. So yeah, this is the earlier slide with the CVE part crossed out, and the last 5 boxes all apply equally to those type of merge requests as well. Here was an example. Florian went and updated this Jira issue, dropped in the commit hash, and out came this merge request. And see this one, we can actually see the proper, proper dark mode also, but the signed off by CKI backport bot. That is our busy bee that does lots and lots of work. You can also see in here, we do have a whole lot of different CI pipelines that run on each of these merge requests to do some sanity checks and make sure this merge request isn't nuts. That is an actual merge request that you can, the URL to it is right there. You can actually go browse to that and see it yourselves if you're so inclined as well.
Can you leave funny comments?
I believe so.
Okay.
If you have a GitLab account, I believe you should be able to see it and leave a comment. Yeah. We do actually have our work split in 2 namespaces. There is this this namespace, gitlab.com/Red Hat. I don't know how visible that actually is in here. Red Hat/CentOS stream. There's also a Red Hat/rel space that is slightly more restricted to Red Hat and Red Hat partners only, which you would not be able to go and see and leave comments in. That's primarily for post-GA work. Okay, so there was a question about, do you look for kernel ABI changes in that? That's and the labels a couple of slides ago. These are some of the automated merge request checks that we actually have in place for all merge requests, auto-generated and human-generated. We do require peer review, as previously mentioned. Need at least 2 approvals from other kernel engineers. There are some subsystems within the kernel that actually have mandatory review from somebody that is a subsystem expert, and those will increase the number of reviews that are actually required on the code. It has to come from somebody in the Cool Kids group. So you can actually end up with a merge request that requires 10 approvals or something like that if your code touches enough different things and with mandatory approval subsystems. Our continuous kernel integration team is responsible for a whole lot of testing, automated testing on the merge requests. There's a whole test infrastructure. All the pipelines that are running there are part of CKI. There's targeted testing based on the code that is modified in the merge request that is run, as well as some basic smoke tests. There's a bunch of LTP, memcheck, and a whole bunch of different tests that are running there. That is actually an area that we're trying to do more and get more automated tests and more targeted tests done, and exploring a bit some other AI-ish things because we're told we have to. I mean, because it's great. Try and come up with a way to test this. Yeah, you know. Yeah. Again, upstream commit references are required. If somebody submits a patch that's, hey, this is random code change, well, where'd it come from? It will be rejected. We don't allow it. It needs to have signed off by, proper signed off by attribution. It needs to have an upstream reference, what tree it came from, preferably Linus's tree, but we actually have a number of developer subtrees that we also accept. We check for, does this commit have missing fixes? Because we don't want to ship something that's known broken. So we actually periodically refresh merge requests and look for, hey, did something just get fixed upstream that we should pull back? Yeah.
You just mentioned that there's other developers' trees that you'll pull from
yeah.
as well. Have you ever had a situation where the tree that you pulled from was not eventually merged into Linus's tree? Does that, do you know what I mean? Like, has it ever been like, oh, well, we should have?
Very, very infrequently, yes. We have had at least a small handful of cases where I think a patch, like an emergency fix sort of thing, was like, oh, we need to do something about this, and we took a draft patch or a version 2 patch of something from Linux Next or from TIP, and committed that because of deadlines. And then the final version that actually went into Linus's tree was different, but we explicitly track those. And will actually go back and in the subsequent update will actually revert and apply the proper upstream version.
Got it.
We are pretty pedantic about all of it, which is actually very necessary for a lot of the automation to function correctly. Like if the mechanical bits aren't there, we can't do the mechanical checks. So yeah, we're very, very annoying to some people at times. We also check config changes. We have, I don't know if anybody here has ever looked at a Red Hat kernel Git tree at how you actually change a config entry, but it's not just a .config file, because in a single kernel build, or kernel RPM spec file rather, we generate, I don't even know how many, probably upwards of 10 different kernel builds. So there's different variants. There's kernel debug, there's kernel UKI, there's kernel, I don't even remember anymore. ARM has like kernel 64K. Anyway, it's a hierarchy. So there's a base level, and then there are individual config files named by config knob name, and then there's this thing that smushes them all together. And this is a difficult thing to sort of wrap your head around, so we actually have this, this Python code that takes the submitted change that the person thinks is right and actually applies it and runs through all the things and says, okay, here's the change you made, and here's the resulting kernel config changes versus before, and does that actually look right? Yeah, it's a mess, but it's actually hugely helpful. Actually, really helpful in Fedora. Every time we rebase on latest Linux tree and there are new config options, it's Justin Forbes, the Fedora kernel maintainer, loves this thing.
Still 15 minutes left for any questions.
15 minutes left for any questions. We've still got a couple of slides. Yeah, user space API breakage checks are in there. Kernel validation, QA testing. How do we validate the changes? We've got the regression tests that are run by CKI, QA gating tests at the final ready for ready for merge state of the merge request. Each JIRA issue. We went through all the checks, the first line checks, and then set the merge request to ready for QA, and that triggers something where we update the linked JIRA issue and say, hey, QA, this JIRA issue is ready for preliminary testing. They do the preliminary testing that's necessary for the merge request and then say, okay, it's done, and that then turns around and sends an event back to the GitLab side, and GitLab merge request then ends up marked ready. And then we have the merge request builds that look for all the ready merge requests and bundle them all together, et cetera, speeding along. So what do we get out of this? What are the benefits? Why? Well, there's all that busy work and all that volume that's taken care of. And these draft merge requests are basically created as soon as possible. So if you as a developer were out for a 4-day weekend and the CVE was reported, Thursday night after you've already quit, prior to this, you'd come back on, say, Tuesday, and, crap, I got to deal with this CVE thing. But in this case, the merge request was submitted Thursday night. It's already been through all of our CKI testing pipelines. We know that it builds. We know that it passes all of our smoke tests. And there's a merge request that's ready for review already. So greatly accelerated timeline for fixing CVEs, and removes a lot of the human delay out of the loop. And just not having to do a lot of trivial busy work with simple cherry pick only merge requests is a huge plus. Technically, we require 2 peer reviews on every merge request, and the assignee of the merge request, or even the person who generated the merge request by inputting commit hashes into the JIRA issue, can be one of the two people that reviews the merge request, which is kind of a gray area that some people are like, that seems sketchy, but whatever. So here's the URLs of interest related to this project that will be in the slides that get sent over to Linux Fast Northwest that you'll be able to grab. You can also take a picture of that if you like. And thank you, and I'll go back to it. The end. Okay, more questions? Yeah.
So do you explicitly create a test that exercises the failure mode you're fixing, and then test that test exercises the failure and fails, and then lists the patch resulted?
Outside of my knowledge domain, but I do believe is something that we are gunning for, but is not something that we currently have. We are actually talking about a future where we do enforce that any merge request you submit for kernel changes should have a guarantee that that change is actually tested. One of the absolutely wonderful things with this kernel workflow project, this is where the bulk of the Python code that actually runs all this exists, is we have, I think we're up to 92.3% code coverage on it. So any change you make there, there's a battery of self-tests that are running every time. If the coverage drops, it's actually a pipeline failure. And you have to manually override that if you want to merge something with the code coverage dropping, or better yet, write more self-tests to up the code coverage. And that is something we would like to get to for the kernel, so that there is a guarantee. If you are submitting something and it fails here, there should be a self-test that accompanies that shows here's how it's failing, here's it's fixed, so that we don't have a regression. And some of that has to do with scalability as well. One of the other issues that we have right now is we have people that are still using RHEL 7, RHEL 6, possibly even RHEL 5. I don't know how far back. We definitely still have fixes going in for RHEL 6 and RHEL 7 though, even though they shipped 15 years ago or something like that. And I think a recent announcement was, are we up to 15, 20 years of support for any given stream if you want to pay for it?
We keep increasing the amount of money you have to throw at Red Hat.
Yes.
And people just keep throwing.
Yeah, it's a great scheme, really. But we're also then expanding the number of kernel offerings we have. One of the recent things was this accelerated infrastructure accelerated infrastructure enablement channel. So there's this now this this NVIDIA kernel, RHEL for NVIDIA, which is basically trying to spit out a kernel that works on the latest NVIDIA hardware that's released every 3 months, 6 months, I don't know these days anymore. That didn't sync up well with the RHEL kernel schedules, so we have now this as well. And a lot of the time the fix needs to happen there and there and there, and it'd be great if there was guarantee that there was a self-test. So, okay, well, we can run the self-test on all these streams and know if it's actually affected and if it's actually fixed or if it's not. So you can scale out the number of kernels you can deliver with a greater degree of assurance that it's not going to explode when somebody tries to boot it. That's our hope anyway. Anything else? Everything was explained perfectly. Love it. All right.
Thank you.
Thank you very much.
programmable logic device, right? So this evolves from the 80s. They start adding interesting things, and there's not just, you know, simple logic. It's configurable logic blocks, lookup tables. You know, when people say FPGA these days, it means a lot of things. It's the CLBs, LUTs, but it's also integrated with a lot of hard silicon IP like block RAM, ultra RAM, dedicated multipliers, dedicated transceivers, these sort of things. So a lot goes into what people call an FPGA. And so this, so the sort of evolution of things, thank you. Thanks. The evolution of things is people have these logic systems, they're building an embedded system, how do we control it? So there's a couple paradigms. People would implement soft-core processors, like for AMD it's was it microblaze, picoblaze, these sort of things. Or they plant a microcontroller or some kind of processor next door to it, like a little power PC thing. But as you know, the trend is always bigger and better, more integrated. You have less problems in circuit board design with your interconnects. People started to build these so-called system on chip. So I always think that the nomenclature is funny because there's system on chip. Well, there's lots of systems on chips, but so most people call the FPGA socks FPGAs, even though these socks are socks, but those socks are not necessarily these socks, right? So it sort of started out early 2010s, at least with AMD, building the Zinc device. Anybody familiar with those? Okay. So basically, original Zinc was dual 32-bit ARM processors on the same chip with low voltage translators and interconnects to an FPGA, either a small or a big FPGA. The processor is like a normal sort of processor package. It's got a MIO section with all the normal peripheral goody drivers that you'd expect, like SPI, I2C, Ethernet, these sort of things. So, bigger is always better. So then there's sort of this idea of multiprocessor SoC. So now and I'll show some pictures of this because most of this that I'm doing here is based on the MPSoC. But quad-core 64-bit ARM, real-time unit of two 32-bit ARMs, floating point units, big, massive, fast FPGA connected to it. And the evolution continues. So the next thing is Versal, and you may see, these are actually the devices under the hood. If you see like AMD machine learning accelerator cards and these sort of things. So they're a big old MPSoC, FPGA, and then a dedicated scalar vector unit, which they'd call an AI engine. And then multipliers. So things continue. And the one I'm really excited about because of my microwave and radar background is the Versal RF. So now you can implement machine learning. You can do all your signal conditioning on the FPGA. It's all integrated in one thing. So they've got high speed, high bandwidth transceivers, AI engine, processors, all this stuff. But the point is the easiest way to control your system, in my opinion, is Linux. And sometimes people want you to do something like RTOS or whatever, or thread, multi-core, bare metal, you're with your own scheduler. But Linux is the way to go, right? I mean, anybody disagree? It's a preach into the choir, right? So just for funsies, this is sort of the architecture cartoon of the AMD MPSoC. So you can see what's going on here. Like this is where what your FPGA is. It's just the programmable logic region, and it's got all the stuff I was talking about: block RAM, ultra RAM, DSP, various. I mean, these may have 900, 1100 pins that you can control the interfaces on various things. Different I/O types, and then high-speed SerDes stuff. So GTH, GTY transceivers, but that means you could do SATA, USB 3, 100G, those sort of things. And then you have, on the processor side, the MIO section, which the neat thing about these guys is you're familiar with the concept of MIO, which is multiplex input-output, right? You can actually port your MIO into the FPGA, so you can also take advantage of the easy access from the processor to general connectivity here. But you can see it's got everything. It's got Neon FPU, memory controllers. It just keeps going on and on. So more about what I'm talking about is a little, under the hood of the cartoon here is you've got the programmable logic, and now you have all of these AXI ports. And AXI is under the AMBA 4 ARM specification. It's just a type of signaling. But you can see you've got, this is probably, I don't know if you can read this, but it's, high-speed master interface, a lot of high-speed slave interfaces, so you can have, in your FPGA, you can have DMA engines that are controlling the memory space here, moving memory in and out. There's coherency ports, so you can DMA with coherency if you want to. I think there's a use case for that using like their Vitis engines for machine learning, and they don't want to get into the nuts and bolts of things. But I never use that stuff because DMA engine, I don't know. I think from the Linux kernel you should be controlling coherency. So what got me going for the sort of motivation for this talk, which is mostly, kernel stuff, is a project that I'm working on in my spare time, which is RDMA. Anybody not familiar with RDMA? Okay, so RDMA is remote direct memory access. So you have a big file transfer in your computer or from peripherals on PCIe. It's mostly, come on in. It's mostly you've done via direct memory access. When I was a kid, you move the mouse and everything starts slowing down. So you don't want your memory controller to sit there just be processor cycles of fetch, move, place, all those sort of things. So use a DMA engine, but it's things the system scale. Now maybe you have a GPU on a machine and you have a remote device that's got data. In my particular use case, there's little reason to and what's normally done, but there's little reason to do it that way, is to have an Ethernet port, your own maybe user kernel space spool of circular memory for this, and then you're moving it to the GPU and all this stuff, when the GPU can just use RDMA protocol to fetch stuff over the network. So there's been various ways of doing that, which is InfiniBand, but there's also what I'm concerning myself with is Rocky v2, which is RDMA over converged Ethernet, which basically takes the InfiniBand protocol, puts it in a IPv4 UDP wrapper, could be IPv6, but for here IPv4, and you get some overhead with that, but you can now use it in kind of more distributed systems where you may be using a switch, router, these sort of things. And the reason I'm pushing on this is I believe it's the right way to move large amounts of data. So if you imagine radar, comms, like 6G, these are massive bandwidth systems. And so I think the low-hanging fruit is you do things in the old paradigm. You come up with your own network protocol, and then you collect the data, you push it to the GPU who's doing machine learning on figuring out the communication path and how to equalize the signal. But I think the right way to do it, which is like where CERN is and some of these more advanced places, they're starting to use Rocky v2 for just moving sensor data. And anybody, please feel free to ask me questions as we go, because I might take something for granted. But back to the MPSoC, on the networking side, they have built-in 4 1G ports. You can use a DMA bridge in the logic and connect to 10G. But if you run iPerf on the MPSoC, it's pretty much good for 2.5 gigabits per second. And so you can see, like, you may have a massive sensor system. You've got this great chip, but really the processor side isn't going to handle as much information as you might want it to. Because the FPGA itself, I mean, you may be doing terabit Ethernet if you wanted to, with the amount of parallelism that's on some of the chips are just massive. So you can do multi-100 gig aware systems. In my case, what I would like to do is just keep the PS in this case, which is the processor system, the ARMs, for command control, light processing, sort of background stuff to keep the system running properly. Programmable logic does all the interesting stuff. Now you could connect your massive Versal or MPSoC chip via Rocky v2, over 100G Ethernet. And so the idea is you could still have everything on the same network link. You could have different IP, different MAC addresses, however you want to do it. But so the processor wants to send out a packet, it gets priority over this system, and it just pushes it into the 100G network link. But meanwhile, you're streaming data in through an arbiter, And then for packets coming in, you may need 100G data in the FPGA, but you can still filter off little packets, the smallest amounts of data that need to go to the processor. So the idea is the processor is always in control, always gets priority, but the amount of bandwidth it takes up is almost negligible. So, and why do we want to do that? Because these massive communications and radar and sonar systems, they just have massive amounts of data. And the paradigm, if you read about these things, is everybody says, okay, I'm going to get my data into the FPGA, then I'm going to use a DMA engine, I'm going to push it into a memory hole in the network, into the memory, and then I'm going to use the network stack to pull it out and put it over 1G. But it's easily pass up the 1G mark on a lot of these data systems. So in my system, I don't know if you can see this, basically these are AXI4 light, AXI4 not light, and AXI stream buses here. But the idea is I basically have a DMA engine here that you can't read, and 100G Ethernet MAC, and PCS, PMA, and then I'm basically inserting something in what you'd normally configure here in the stream. And that's basically the massive data handler. And mostly what I wanted to talk about while we're here is the command and control of that via the Linux kernel. So I'm curious, probably lots of kernel space people that know more about it than me. User space, kernel space. Anybody kernel hackers? Okay, all right. So maybe this will be interesting because you get kind of a taste of what happens on a platform driver. So I probably should speed up a little bit, but the point is AXI is part of the ARM AMBA specifications. So there's a lot of different bus protocols, but what is implemented in the system on chip, exposed into the programmable logic, is a bunch of AXI buses. So how can we take advantage of that? They're hardware addressable locations with arbitrary address space. So you build your peripheral in here. You can define the hardware address of this, or you can let the machine decide what the hardware address is, and then all these parameters are exported for device tree generation and that sort of thing. So just I don't want to get lost in the semantics here. RTL, there's RTL languages. This is Verilog on the left side. This is just the real-time AXI light port in the FPGA for this register space. But you can imagine here, so imagine in memory you decided, and it works obviously a lot different, that you want 32 UNT32 registers that you want to command and control of. Well, here are their hardware addresses as opposed to some virtual memory space in the user and kernel, right? So what you end up with is you may have like your memory space is 0 through 4G or something like that for your RAM. And then this address is some hardware address extended beyond that. A little bit about the protocols. I'm just going to keep moving. Since this is a Linux thing, anybody familiar with device trees? Okay, good. So the idea, for those who aren't, is that what do you do if you don't have like BIOS or a hot pluggable device and driver? You need to have some way of specifying what is connected to the chip. So this sort of comes into a lot of ARM system on chip things where there's things connected, but there's no way for the kernel to probe it. U-boot, the kernel, whatever, at boot time. So it's just basically a tree structure that has a definition of a lot of things, and this is a lot of semantics, but the FPGA tools, XST, when you build it, you can export your system, and it'll create a DTS file. Like here's what it exported, PL, UDP, arbiter, clock names, blah, blah. All this stuff's not really relevant, but for your platform driver, you need it compatible. And so they're saying XLNX, which I don't work for XLNX, so in my own device tree overlay, I write my own compatible string to write it over. And then in your platform driver, this is match later. Like so I see here, device of match, Susatronics, PL, UDP, arbiter. So, and I was going to show some of the kernel code too, but this is basically the part in the platform driver that matches what you want to do in the platform driver to what's in the device tree. And obviously, if you have this driver loaded, but you don't have this in your device tree, it's just gonna, it's not going to probe. It's not going to finish the probe properly. Okay, so just for fun, and what I want to show is how some of this stuff works is it's very easy to define. Oh, you probably can't read that. How do you turn on light mode? Oh no. Let's see, I don't know how to do light mode.
Nobody's ever asked that question before.
Yeah, right?
Turn the lights off in here.
Yeah.
Turn dark mode on in the...
Dark. Should have checked that out first. It's probably hard to read, but basically, just like you would have in a header file, you're defining your 4-byte offset for a 32-bit register space. This is basically just the 4-byte offsets in the FPGA, defining what pins do what, that sort of thing. So this talk really is about command control from the Linux kernel, so that's why I'm showing this. I was saying in my RTL code, I have I basically have this as my control module, and I can write to anything on this bus and assign register values for controlling the system. So if you're not familiar with platform drivers, which I'm probably not the biggest expert on, essentially you have a probe and release function. And so here you can see this of device ID, and then this is connected to the driver via this platform driver struct here. And so you can say device name. God, you can't read that, can you? Can anybody read that? Ah,
You
okay.
can try like zooming in.
Yeah, let's see.
Oh, so much better.
Yeah, let's see if we can go bigger. How's that?
Oh, better.
Okay, thank you. Yeah, you can actually read it now. So really, the init and exit functions are normal to just about any kernel module, right? So those need to be in there, but then you have this platform driver structure. It links to this of ID thing that connects it to the device tree. And then in the probe function, you can say, get resources, get the memory space, get the memory locations. This is going to be a MISC device, so it's going to assign, what is a MISC device? Major number of 10 for the car driver, and then it comes up with a dynamic minor name number. And then you do the polite thing in the Linux kernel, request mem region, so this driver owns that physical hardware space. Then you IO remap, you bring that hardware address and get the kernel address for it. And now you can use IO write, IO read friends because you have the virtual kernel memory address now. So, but anyways, long story short is this platform driver, it populates in dev and it creates a normal character driver. And so now it has open, release, and I don't know what people's take every time because I'm not a Linux kernel guy, I always read about ioctl, and it seems to be a continuing debate. Is it still a continuing debate? I mean, I think people here might know more than me. Any comments on? So apparently ioctl is a very old way of controlling things. So if you were going to open a driver from user space, you'd open, and there's various ways. How are you going to control a hardware device? You could think of creative ways to do it. There's sysfs now, but right. So, but the old school way, which maybe is the best way, is ioctl. So a driver, if you look at a lot of low-level user space commands to hardware, you'll see ioctl. And in this case, I'm basically just creating various structures to pass to the kernel via ioctl to do the command and control for me. So it's open, close, normal driver stuff, and then just ioctl writes and reads to get the command and control information out of the FPGA in a very Linux kernel-y way. You could do this from user space in Python or C or whatever and memory map the hardware addresses and all that. But that's sort of a hack. So that's why I went down this road and just scratched my head a few times and thought, what can I do in kernel space? So I think that's all I have for my talk. I don't know if that was educational or not, but it's a brief touch into system on chips and running Linux on system on chip and creating a kernel module for a system on chip, a platform device. You can see a person who talked for a long time, please.
Do you happen to have one with you? Just curious.
No, because they're a little spendy, you know, and static sensitive. So I thought a show and tell would be fun, and I was like, I had a lot of stuff in Seattle, and so no, I didn't bring one with. But this particular system, I mean, I can show you. ZCU 102. This is the particular board that I'm using for this project for evaluation. Let's see, there we go. I mean, this one isn't that expensive anymore. It's only $3,500, right? We just bought at UW. They haven't released the Versal RF, but they have engineering silicon boards now. If you're not a big fab, board builder, and so I spent the last 6 months trying to get my hands on them. But this board for that chip is $35,000. So it can get expensive fast. But the stuff you do with them is amazing, right? But no, I don't have one with. Yeah.
So is Linux running on the FPGA?
So you could do that, but in this case, it is running on the ARM core, the quad ARM cores on this guy. Good question.
And then what is the FPGA used for?
So the FPGA in this particular project, like this is part of the FPGA project, the FPGA is handling the real work, the Rocky V2 stuff, the Rocky V2 stack, and all of the initial signal conditioning, like down conversion, filtering. These signals might be just one channel might be 10 gigasamples per second or something. So then multiply that by 16 bits. And that's just one channel. You may have 8 channels or more of these things. So you've got like T-flop sort of signal conditioning and processing before it even gets to this stage.
The data that's coming from like
like maybe you've got a sensor or some really advanced communication system, and so maybe you're doing beamforming, so you've got multiple high bandwidth channels, and you're doing the channel summation and filtering and down conversion, and you still have a big fat pipe of data, but you've taken it from sort of the tera scale or more down to the 110 sort of gigabit level, right? Yeah.
So is Ethernet being connected, or the Rocky V2 is
therefore the
is that being
Ethernet
connected straight to the FPGA?
Yeah, that's connected to the logic side of the FPGA, and then how you would do the communication from the processor normally through the FPGA is you would I mean there's schemes for this already. MacB driver, there's drivers for it. You put the soft DMA engine in there, and it does all the fetches and sends of memory, and those turn into these AXI stream signals. They go to whatever the particular MAC is for this, and that sort of thing. And then it's got the same usual Ethernet friends, MDIOs controlling the MAC and onto the PHY, and the same normal stuff. But like a 10G, 100G, that's all sort of completely in the FPGA, whether it's hard silicon or IP or custom IP. Because you've got, depending on the protocol, it's obviously high speed, but you've got like the physical coding sublayer and all those sort of things all implemented there. But yeah, you could do this with 1G, with a DMA engine and a tri-mode MAC in it, and we do those things all the time. Just trying to beef up the pipe here for this particular project. Yeah.
For your stack for programming the FPGA part,
Mhm.
are you able to use mostly open source? Or?
No, sadly, there's very few devices that the hardware has been open source, and there have been a few old ones and maybe at a different manufacturer. But no, sadly, all of these, and there's always attempts going on to try and reverse engineer them. But at some point, you have to be careful because they're used in a lot of things that you're not bending ITAR rules to. So me personally, I'm all about optimization, genetic algorithms, and there's been people that have used genetic algorithms to configure the open sourced FPGAs, which I think is fascinating. So you don't even need to write the logic for it. You say, I want the inputs to be this, the outputs to be this at a function, and then you just run a optimization algorithm until you get it right. And that people have done that. It's very interesting. But no, not open source. The best you can do is, use the, luckily now in the last 10 years, they started making the software capable on Linux, which was nice because it was tough software before, and then you're on Windows, and so yeah. So they've got their own distros they prefer, but some of this stuff I showed here is, even though they want it to be on like Ubuntu 24.04 or something, I might put it on Debian and spoof the OS name just so it plays nice,
Yeah, so you mentioned pumping up the registers on the FPGA with the ioctals. So what kind of latencies do you see with that?
Well, FPGA side, very deterministic. That's the one thing about FPGAs. You can do this deterministically, but it would be the same as any uncached write, read, real. I mean, DDR, you've got the DDR controller, so there's latency there. In this case, you've got bus transceivers, and switches in the processor. So honestly, I've never bothered to measure that, but in this case, those registers are being clocked at 25 megahertz, which isn't fast, but it's plenty fast for anything that you'd want to do. You could definitely have a 300 gigahertz bus to memory locations if you wanted to, but it's a good question. It's so negligible, and I already know the processor is not deterministic, so I'd say it's the least of my problems. Yeah, it's a good question. Yeah.
Is it actually running then?
This one? Yes. Yeah. This one, I haven't implemented the full Rocky V2 stack. There's different levels of what's okay on Rocky V2. So what I'd like to do is lossy Rocky V2, which would mean that, for sensor data, you don't have to have a big memory stack to recover if there's a drop packet and that sort of thing. So AMD does have a Rocky V2 IP, but it's massive and it covers all of the different parts of Rocky V2 protocol. And so it's so massive, they don't even want to use it for some new stuff they're doing. So I'm actually working with them to use this for a demo design where they're hooking it up to a camera system, but the chip's too small. They don't want to have their big Rocky V2. They won't fit on the chip even, so they want the lightweight things, which I think is kind of funny that they're asking me to implement something they've already implemented.
So you're throwing parts of Rocky V2 out?
Yeah, essentially, yeah. I don't care if there's a drop packet, because generally the data bandwidth is so high, it's easier to recover from missing information by ignoring it than it is trying to make sure you don't miss it. Certainly could implement a lossless stack. I'm not personally interested in doing that. Yeah.
So how much of the FPGA are you using?
Oh, this one, just the stuff I showed here. 1%, the Rocky V2 one of this particular chip, maybe 4%.
Wow.
Yeah, so this is a big chip, but it's a lot lighter because you don't have, just like if you were trying to implement your own TCP stack versus UDP, right? UDP, you're like, nah, it's gone, who cares? TCP, you have to always have, have it in memory until you are verified that it's gone, and that would be the same for lossless Rocky V2. And why you have memory connects and all this stuff, and you could do it, I'd rather just pipeline everything, get it out of the way, and move on with the day. But yeah, on this guy, fractional, very fractional amounts.
And then you mentioned another manufacturer that makes something an FPGA that does have open source tools.
Yeah, I think there's a microchip FPGA that is open source. I think it was reverse engineered by the public, if I remember correctly. But otherwise, they like to keep it proprietary. So how the bit streams are encoded, you can't really, they're encrypted bit streams, and so a lot of that shenanigans, you can't really look at a bit stream and reverse engineer where it is. You can tell, if you want to, the system where you'd like this logic to be placed. And I don't even think you need to do that anymore. In the old days, you'd kind of constrain some of your systems to certain parts of the chip. It was like pre-planning where things are going to be to optimize because the build times on these were day level for big chips 10 years ago. And they've done a lot, but it's basically a single thread when it comes to place and route. And place and route is like, okay, so you're targeting, let's say 300 megahertz, and you're going to have all these registers. You know, it tries to put them in logical same places, but maybe on each clock, there's not enough setup and hold time on each clock cycle. So it's like, no, scratch, rip it up, do it again, do it again. So it's getting better, but it's still a single-threaded optimization, or single-threaded system. So it's an ongoing, active, extremely active research area, like how to speed up the place and route on these things. Because there's a synthesis stage, optimization where it trims out logic that it doesn't need, and then it goes to PNR, and that may cycle 10 times before. So if you only have a little bit, like 5% of your chip, unless it's really high clocked, it's probably going to land right the first time. But as you get now, let's say you get to 95% utilization, and it's trying to stretch out these register buses so they line up in time. And now it's got to move across like a chip internet because there's multiple silicon pieces. It can get crazy very quick, you know, on how long it takes to do the place and route. But this is how like any modern chip that isn't reconfigurable is done. They use the same languages, they use the same premise of the tools. But the reason why chips are really expensive is they spend a lot of time in verification. Here, if I make a mistake, I change the code, rebuild it, you know. But FPGAs are commonly used for ASIC verification. So you're going to tape out an ASIC. You can run simulations, but the simulations are slow. And maybe this guy is going to be, you have multiple, you may do parts of your logic on a single FPGA, or you're going to do a big chip, and you're going to have dozens of FPGAs with bus interconnects in between them. And then you're going to run your system on the chip at a slower rate, but you're sending it all the stimulus and problems that could happen to see if anything falls out of the crack before you spend another whatever 100 million on the foundry and the tape, the actual tape out of it finish. So they're used in verification a lot too, and then also high frequency trading. So basically comms, high bandwidth networking, defense-y stuff like one-offs, run-off research projects. High frequency trading, people used to use CPUs and they went to GPUs. Now they use FPGAs because they're trying to trim off nanoseconds for calculation time because they just gotta have that money, right? I find it, I mean, I'm not wealthy, but I was gonna say I find it soulless, but I'm also not wealthy, right? But some of the people that are good at this, you could go to New York, London, Chicago, and I don't know, make $500,000 a year because in bonuses if you're trimming transaction times off. But that's like optimizing your NIC, optimizing your CRC, optimizing everything just over and over, trimming a clock cycle out here and there, which is amazing. That's where we're at. It's high-speed crystal clock cycles that you're worried about for trading. But yeah, like nowadays, if you bought a PCIe card in the old days with a 10G NIC on it, it was probably an FPGA. Now there's probably still 100G switches that don't have their own dedicated ASICs. They're using FPGAs. I'm doing like space router stuff, and we're using FPGAs for that, And so, but it's always where the high bandwidth is. Yeah.
Aside from low volume products and research projects, what are some contexts where you need an FPGA rather than an ASIC?
Well, the ASIC would always do what the FPGA does, better, faster. But how many of these things do you want to make? And that's why the ITAR thing comes into play, because people aren't making, and I'm not, I don't want to get into a political argument. I've got little kids, I don't like blowing things up. But you can see the applications for this where you're only building dozens. There's no reason to tape out an ASIC for something that you're only going to make dozens of.
Like with the HFT application, where they want an FPGA so that they can be constantly tweaking an algorithm?
Yeah, okay. As opposed to taping out an ASIC. And I knew somebody who was an FPGA and ASIC guy, and he started building a prototype FPGA for dedicated HFT. And he was talking to Samsung about tape outs and stuff, but I mean, there's already people doing that. That's why if you were into mining, right, like blockchain, you can buy the lower, power is your enemy in trying to score coins with blockchain. So you buy the dedicated thing. They're probably, now they were FPGAs, now they're ASICs, that people are using because it's lower and lower. You use much less power and it's faster with an ASIC, but it costs a lot of money to make an ASIC, right? be over on time. Yeah.
So the Rocky V2 thing, that's like a data protocol?
What's that?
Is that a data protocol?
Yeah, so for RDMA, you could imagine having maybe a machine running and then GPUs or memory locations on other machines. And people used the InfiniBand protocol for RDMA, which is, they basically the same, who cares what the physical layer is. They're networked machines, and instead of doing DMA from like a device or memory location to memory location locally, you basically have this network protocol to reach in and get or place memory in another machine. So Rocky V2 is just an evolution of that, is routable InfiniBand essentially. So it works with, so if you see like a Mellanox 10G card, like DirectX 4, 5, maybe 3 something, they have like Rocky V2 built into them. Even though they're a typical, NIC, they also support these protocols, and the drivers support, the InfiniBand, Rocky V2, Rocky V1. There's another one, I don't remember what it is.
So you're getting the data and processing it on the ARM chip and then sending it like across the chain?
Yeah, so you can imagine distributed machine learning. So say for like the Versal device where this is targeted, you would have a bunch of data streaming in to the FPGA, you do your processing, maybe some early processing in the AI/ML tile, and now it gets shunted into memory, and you have a queue in memory that's not connected to the processor, or it could be connected to the processor, and you have a DMA engine running. And now you have this Rocky V2 stack, and you make a query for data at a certain location, it squirts it out, the master sends yeah, got it, and the whole thing continues on. So you could imagine at a minimum for this sort of data system, it's just having the ping pong addresses, like even 2 memory locations that you always ping pong between to retrieve data, because if you're retrieving from one, new data is flowing into the other. Or you could have a big spool, a big circular memory buffer, however you want to do it. So I was going to make it, I mean a ping pong buffer is a 2-piece circular buffer, right? So, yeah.
Thank you.
Yeah, of course. Yeah. Thank you, everyone. I think we're well over on time. I'm going to get the hook in a second. So thank you very much. Yeah. Okay. Good. Okay. Thank you.
Yeah, I'm trying.
You're doing good. Yeah.
You going at either 4 o'clock talks?
Yeah, I thought since I live up here, and I thought maybe someday I'll get old. I live about 15 minutes south. I thought someday I probably won't be able to afford retiring, so I should teach this. Just because I think. What's that? Which department? Computer science. Are you involved with that, sir?
I am. My wife is in history department.
Oh, very cool.
Yeah. I know Caroline, how do you?
Okay, yeah. Okay, very good. Yeah, and the way I always thought I'd try and get the foot in the door when I could, but they weren't hiring adjunct, but my neighbor is tenured faculty there. Yeah,
So I think we should
Thank you. I think I'm going to step up just yeah, that's the thing I could fucking do. I was going to say.
She might just be. Looks like they might be open. I think they might be. I'm like instantly getting panicked. I'm thinking it's poor air quality. Oh hell. I do something really cool. Oh, sorry.
Yeah, it's kind of around minor square.
Oh no, I literally have a CFP I'll bring you guys over. What is
So other than being able to plug in the HDMI cable and then there's the camera, the HDMI is routed to room audio as well?
Yes.
Awesome. I'll finish up here and we'll connect.
But it wasn't. Yeah. That's what he came back. He said something the organizer the other question So like I guess my point is if I can still so you said you were just a special website.
Full sign is about to fall off the door.
You know, I keep watching it.
Yeah, I think it has to be like drop down to the bar. You can see there are
My point is that it's supposed to come back it's supposed to be
walk through instruction.
You just released Still OS last year?
What's up?
Was it just released last year? Which? Still OS.
Haven't heard of it.
Am I in the wrong talk?
This is going to be about user data protection at the border and then hostile environments.
Oh, perfect.
You're welcome to stay.
Now that I made it in.
Very textual.
This is 235. 36 is.
Next one over.
Difficulties? No, he's just finishing.
Yeah, it's not
There's one seat.
Is the transcription reading your mind? I'm actually kind of curious about where the transcription comes from. It doesn't seem to be running up here. I'm not sure what a beautiful juice period is.
Weird stuff up there earlier.
I kind of wanted to do really?
Oh, hopefully those weird subtitles aren't baked into the recording.
Well, if they are, we can have fun.
fairly certain they are.
The subtitles on the one that
I was going to do the first person. Being too quiet for it to get good signal.
Censored the word in the transcript.
Because they're, when you load Firefox, it mounts it as read-only boxes.
Right. We've got 3 minutes before we start up. I'm going to correct a message I sent out to a bunch of people about the link for this chat, for this talk, and then we can get started. It does seem like we're planning for 15-minute Q&A after the 30-minute slot, correct? Okay. So during the talk, I'm going to be going over quite a bit of stuff. I'm also going to be at some of the events following this, so if people have questions or if something doesn't make enough sense, I'm happy to answer technical questions after the Q&A. If we want to talk about high-level questions, then that would be what we're targeting for the Q&A. Not that I don't want to talk about it, but the point of this talk is not a step-by-step guide. It's an overview of what to think about and how to approach the problem, if that makes sense. But if we don't have questions and we go back to the technical questions, bring them.
I know your talk, but
do we have space for one more?
Oh, we just
Just do one chair as.
You can take this one. I'm not going to use it.
you got it.
All right.
I already know your talk. We good.
All right. Bye for Ann.
You're too popular.
That's a good problem to have, ain't
To
it?
bribe the fire marshal.
Yeah. Just knock down a wall.
Set up a system of mirrors and a speaker down.
Live stream it to a different room.
Okay, that would be too easy.
I like the mirrors.
All right, we'll go ahead and plug in here, get some water. Y'all know the feeling of being in a school project or a presentation where you overestimate the time it takes to put icons in a place, so you end up with a bunch of bullet points? Yeah, me neither. Kidding. All right, let's get this up here. Before I get started, I'm going to ask a couple of yes or no questions. And by a show of hands for yes, I want to try and gauge the technical level that we're working with here. I'm going to do full mirroring. Am I supposed to see this here?
Yeah. Is it a MacBook or?
It is.
Okay. I'm trying to remember.
So this detects an output, but I no see it.
Yeah, I can't remember.
Is there a special thing?
Yeah, there's something with Macs that we have to do. I think I picked this one up.
Yeah. Yeah, okay, it lost it. And maybe. I will re-plug it in over here. It's sad.
Yeah.
All right, so this cable goes where? This is going over here to this monitor. No. Tracking that one? Oh, okay, it's here. Yeah, yeah. So we got it going in, but it's not coming out anywhere.
Hi, it's a MacBook.
Am I special?
Well, yeah, Macs won't support.
Can't remember.
And this one goes into here. And
Okay, we detect it here.
yeah, you'll probably have to restart this.
While they're figuring this out, just by a show of hands, again, raise that looks cool. It's not mine, but it looks cool. Who here knows what tail scale is?
Yeah.
Who here uses tail scale? Who here knows what nebula is? Who here uses nebula? If I say mesh overlay network, do you have an idea of what that is? Okay. If I say port knocking, do you have an idea of what that is? More than I thought. Very nice. Hey, look at that. It's a terminal. Let's get that out again. If I see ZFS, ButterFS, Snapshot, or Samba, do you know what that is? Okay, there we go. If I say virtual file system module for Samba, do you know what that is? Okay, okay. If I say Tux the Penguin, do you know what that is? All right, there we go. All right. Hello, everybody. Welcome to this talk. It's called the Ghost Protocol. We're going to be talking about using your self-hosted infrastructure to operate in hostile environments. This can mean a great many things. I'll tell you a story about what that really means here in a bit. But first, let's go over what this talk will and won't be. This talk is, it's an anecdote for awareness. I want you to be knowledgeable about what is going on in the world today. And I'll be doing that from my own lived experience. This is a demo for thought. We're going to be able to go through the concepts, the high level of what's going on with this tech setup that I'll demo, but we won't be going into a step-by-step. It's an ask for awareness. It's not just what's happening, but it's what's in process, especially when we're talking about the concept of civil liberties and privacy in the tech sector. It is also a call for action. I want you to listen today and do tomorrow. I'll talk more about that by the end of the talk. This talk is not political commentary because privacy is not partisan. We have that right and we should respect it. It's not a debate, but if you want to buy me a beer, I will talk to you about it. It's not a step-by-step guide. You can read my blog for that. I'll talk to you later about where to find that. And lastly, it's not judgment. Each person is going to have a different set of core values, and you're going to have a different way of approaching how you respect those values. If my way is not your way, that is fine. I like oatmeal raisin cookies, some other people don't. So, who am I? My name is Justin. I am a free and open source software enthusiast with special interest in accessibility and in privacy. Accessibility because I am legally blind. I can still see, it's not that great. I've only driven on the sidewalk a couple of times. You can see some of these concerns in a different presentation style in a talk I gave for the Elementary Developer Weekend in 2021. You can find that at edw.elementary.io. The talk of it is my experience as a visually impaired developer. Now, as a blind person, I also race motorbikes. It's a fun time, gets me away from the screen. I also travel quite a bit. You can see here that I take care of myself and my Steam Deck on the plane. It is buckled in tightly, more tightly than myself. I am also the VP of Engineering and Infrastructure at Sention Managed Endpoint Hardening. I needed to say that to get this trip paid for. For the rest of this talk, I'm going to steal a soundbite from the wonderful show Hybrid Cloud Show and remind everybody here that
our views here are ours and not those of our employers.
This is a screenshot from my boss earlier today asking me what I can put in about my employer and what I can't. So this will be my thoughts. My title doesn't come with it. To remember that, I'll just say that when it comes to the job and the talk,
I don't know, I just work here.
cool. So let's get into it. What is privacy? Privacy has many definitions. This will not be an exhaustive list, but the first one that I want to look at here is privacy is the state of being free from disturbance or observation. Disturbance or observation. Let me give you an example. Let's say you are a good child and you want to talk to one of your parental units, and you give good news. I have got a job. You give that news in good faith that your parental unit is going to protect that information with the privacy and the trust that you have established in that relationship. And like a good privacy-respecting mother or father, they go and tell their best friend and their coworker, who then tell other coworkers and people in the city. And eventually everybody knows that you have got a new job. This is observation through a third party. You didn't tell those other people, but someone told them on your behalf. And it can certainly create a disturbance if you owe someone money, because now they know you're getting a paycheck. What's another definition? Privacy is the control of information and its interpretation context. It's the control of information and its interpretation context. Well, you might say information is just information, context doesn't matter. But I'll give you an example. Context matters. When I'm prefacing an email, if you were to take these statements out of context, to whom it may concern is a boring greeting. It's cliche. It's devoid of meaning. To whom it's about to concern. This is exciting, innovative, a call to action. But taken out of context, it's a reason for HR to fire you. Privacy is the state of being free from disturbance or observation. Your information stays your own and doesn't create issues. It is the control of information and its interpretation context so that your email greeting to your buddy doesn't leave you without a job. You just told your mom you got it. So, I have a story. For the last 5 years, I've been moving around and working as a remote developer. In 2023, I moved to Medellin, Colombia. I started working for a US company. This is a lovely workstation on a plane. Same flight where I buckled in my Steam Deck. While working at that company, I was the lead engineer for an overlay network. Think Tailscale or Nebula. This is a network that is not a physical network, but something that sits on top of another network so that you can talk to your computers while still using the public internet and being private. This particular product was used by international companies and governments. The goal of this product was to protect communications between the people who needed to send them from the people who shouldn't see them. Think business secrets, think government secrets. This isn't a product that some governments are going to take kindly to, so one day while I was doing a routine return to the US, I'm going through customs, I pick out my passport, only to be then greeted not with a "you're free to go," but a "you need to come with us." It was at that point that I
Prepare to enter the scary door.
the back rooms, so to speak. Continuing the story time, after I was taken unexpectedly with my devices in hand, my devices are running, the computer's powered on, biometrics are enabled. In an environment where I expected that I would be okay, I was not. The devices were taken. The passwords were demanded under threat of arrest. Now, me, being aware of the Fifth Amendment and how it relates to encryption, I knew that I did not have to produce a password, and none of you do either. Because encryption is considered the destruction of information, therefore decryption is considered the creation of information, and you are not obligated to create information against yourself. But your biometrics are not protected in that same way. Officers can take your finger and put it on a scanner. Officers can show a facial scanner and put it up against your face. These are not sufficient methods to protect your privacy when you're moving through borders, checkpoints, or working with law enforcement. I didn't know that. The devices were taken out of my sight. I had no idea what was going on, why I was stopped. All I knew is that the device was taken, and a few hours later, I was given my devices back. Still no explanation of why I was taken aside, why the devices were taken. I was let go off to my next flight. I made it, and on that flight, I started to look at the device and what had happened. 2 unknown USB devices were connected. On its face, that doesn't seem too alarming, but at the same time, every file on the file system had its access time updated. That would mean that those USB devices have now copied all of the data off of my device. Now you might say, but Justin, if you have nothing to hide, why do you fear someone looking at your data? I have cloud credentials on there, AWS keys. I have certificate authorities for networks such as Tailscale and Nebula, the releasing of which would completely defeat the purpose of the security of that network. You might also say, okay, but these are the good guys. Why do you worry about those people having your data? Because while that device was out of my possession and connected to another machine in a search that was not justified, those same SSH configurations and keys were used to access systems that I can prove with logs. This goes against the Customs and Border Patrol policies. The protections that I was guaranteed were not respected. The privacy was not maintained. Now, in this example, I have to assume that everything was copied and therefore compromised. I no longer have privacy. My digital life is on someone else's computer. So the privacy was violated. I don't have control over the information or its context. I don't have the freedom from disturbance or observation. My password manager, my sessions, my accounts, my photos, my everything is taken. Now that's my story, but it could be with any case. It doesn't have to be a government. It could be your neighbor. It could be your friend. It could be you getting picked up in a data breach. Your data is your life in today's world. Your data access is your privacy. I will never have the same level of privacy that I did because I don't know where that information is or how it's used. I don't know what profile is built. I don't know where my pictures are. But I don't want this to happen again. And so as someone who works in the security field, as someone who is traveling 20+ times a year, entering and exiting countries, I want to do the best that I can within my legal abilities to prevent the breach of my privacy again. So how do I do that? This is the part where there was going to be icons. We didn't get icons. But my solution here is this. No data of mine is going to cross the border. That means that I would have to back up and wipe the device. If it's not with me across the border, it can't be seized. Now the backups have to be safe and reliable. So what do we do there? Well, first we self-host. We have a backup server of our own. If it's in the cloud, it's just someone else's computer, and if it's someone else's computer, we arrive at the same problem. So we self-host with any operating system of your choice. I choose to use a file system that's going to help me out with this. ZFS for data integrity, storage, and encryption. This means that when the computer is not in front of me and not running, the data at rest is useless. But in order to do a backup, I need to get data over the network, so I use Samba plus VFS Fruit for transport. Samba is a file sharing application that will allow you to send and receive files over the network. You've likely used it even if you don't know what it is. VFS Fruit is an extension to Samba that allows Time Machine for Mac OS, because I use a Mac, to store files on a non-time machine, a non-time capsule device. So this means that I can store my data from my Mac on my self-hosted server and encrypt it with ZFS. But I'm not always at home. Sometimes I need to cross a border and I'm not going to be in the same room as the computer where the data gets stored, so that means that I need to access it remotely. I don't want the public to have access to the file server, because then what's the point of having it secure? So I use Nebula as an overlay network. What an overlay network does is it allows you to establish secure tunnels between your device and your other devices over the public internet, but without someone being able to see the information that you're sending. Tailscale refers to this as an exit node, if you want to do it for arbitrary traffic. Nebula refers to this as a lighthouse to establish a connection between these computers, and then you have various types of tunnels that you can move between to get your data in and out. I chose Nebula for this because Tailscale is dependent on a company and an SSO provider like Google. And so if Tailscale were to take down its discovery servers, or if I were to be locked out of my Google account, then I wouldn't be able to access my devices. With Nebula, I can. But I don't want to manage Nebula manually. So I made a tool for it. I'll give a preview of this tool right now. If this doesn't make sense to anyone in the room, that is okay. Here is a working version of the Nebula Management API. What this is going to allow us to do is to register and configure our Nebula nodes programmatically. This means that you don't have to drop to the command line and create a certificate authority. You don't need to create and sign certificates or create configurations by hand. We can simply create a client. Now in this case, I have a few clients that have already been created, so what I'll show is if we just list the clients that we have from the demo that I was doing earlier today, I'll zoom in on this, then we can see that we have a couple of different clients here. One of them is a backup and one of them is a Mac. This is for a demo network of the backup and restore system that I set up in VMs prior to this talk. And if we wanted to get the configuration of any of these, then I can take a valid name, and ask for its configuration. So if I try this out, I now have a Nebula configuration. What this means is that the benefit of Tailscale is now available to me. Just by a show of hands, who in here has used Tailscale but not Nebula? Who in here has used both? Okay. Who in here has used Nebula but not Tailscale? Okay. So in Tailscale, when you connect to the system, it will manage your certificates for you. You get a nice web interface to do that. In Nebula, you don't. You would have to sign your own certificates. An example of this would be, I don't have it in my bash history because of this API. So I'll relegate that to technical questions. But coming back here. Remote access is tricky, so I use Nebula. I don't use Nebula manually. I've created a tool for it. I will be releasing that tool this weekend on GitHub for people who want to play with it. It dramatically simplifies the deployment of Nebula. You can use it in conjunction with Defined Networking, the creator of Nebula. Defined Networking's app with automatic configuration refresh, and you get most of the benefits that you would get with Tailscale, including the ability to completely self-host it. This solves the problem of then being able to connect to all of these devices, the self-hosted server with the Samba file server. However, when I'm traveling and I'm wiping all of my devices, I now have no data on these devices, but that also means that I have no access credentials. I don't have my certificate. So how do I access that? Well, I'm not going to memorize it. A certificate is long. It's ugly. So I'll use port knocking. What happens here in the concept of port knocking, if I say router, who knows what that is? If I say packet, who knows what that is? If I say port, okay. So the concept of port knocking, and who knows what port knocking is? Okay, about half. So the concept of port knocking is this. Your router is aware of when a port receives a packet. If your router is port knocking aware, what can happen is by default a port is closed. So if a port is closed, I cannot access a service on that port. But if I don't have any devices like an SSH key or a network certificate to get in and to connect with that router, what I can do is send a packet to a specific set of ports in a specific order in a specific timing, like knocking on a door. If your friend comes up and you know that they should knock 3 times, but someone else comes and knocks 4 times fast, you know that that's not your friend. It's the same with packets and port knocking. Once you have port knocked, sent the packets in the order and the timing to your router being aware of port knocking can then open up another port. In this case, it's opening up the port for the registration API that gives me my certificate and my configuration to connect to the Nebula network.
Can it do it just to your IP that it's getting?
What's that?
Like, can it say just for your IP?
I could also do that.
Okay.
In this case, because I'm often traveling, I don't know what my IP is going to be.
Yeah.
Now, what that then means is I can travel with my devices wiped and no data, but my data backed up and restorable. I can travel with no access to my overlay network, but the ability to get back into my overlay network solely with something that's in my head. And once I'm back in the network, I can restore my Mac using Time Machine. The benefit of Time Machine is it's a bit-for-bit backup. It's a full disk backup. And so by the time I've restored, I'm up and running. I can open my laptop, and if I had a YouTube video playing at the time that I wiped the device, that same YouTube video is going to be playing when I've restored my device with all of my sessions, my programs, my running applications, and everything. I have very little downtime in this situation. However, I still have to deal with remote encryption. Remote encryption is particularly bad because if power outages happen, restarts happen, freezes happen. So what happens if the server that has all of your files is outside of your grasp and now frozen? You can't get to your data. You can't get to your network. You're locked out, and it's as if everything is deleted. And that really sucks at 4 a.m. when you've just gotten into Spain. So I've started using a Pi KVM. This is a self-hosted IP KVM that's a keyboard video monitor. It is the ability to remotely control your computer as if you're standing in front of it. Where some of us may be familiar with VNC, RustDesk, TeamViewer, RDP, these types of remote access tools. What they don't allow you to do is control it from boot to die. You can configure the BIOS. With some of these, you can attach startup disks. You can completely re-image and manage a machine from halfway across the world. I'll show you how this works. This is PyKVM. It is the web interface to this box that happens to live right next to the server that I'm going to use. If I wanted to get into this server, I'm now using this server with relatively good, yeah, that's coming through, with relatively good response times. There's physically a Raspberry Pi connected with special hat on top of it to receive and decode and send the video, as well as receive my input from this browser and send it as if it's a keyboard. This looks like typical remote access, but what happens here is I can completely shut this machine down. I will now power this off. So this would simulate a power outage, a complete failure, a system reboot without you knowing about it. But because I have this access, which can also be opened up to you via port knocking, or it can be opened up to you via your Nebula network or your Tailscale network after you've gotten your certificate. This is now completely restarting. This is my BIOS boot screen that we just saw. That means I have complete control over the device, even though it's powered off. Meaning, if I wanted to re-image it, I can upload an image and boot. But in this case, I just want to simulate a power outage. So here, what I'll do is go to my power button, do a short click as if I've just pressed the button and released. And in a few seconds, I will see my post screen. If I wanted to, at this point, control my boot devices, I think I pressed it. I didn't press it, but now I am at my boot screen. This is my encryption screen. I know that if the power has gone out, the data on this device is not readable, but I can still get into it, even though I'm halfway across the world. And so, all right, yeah, that is dots. So, wouldn't that be something, a privacy talk where I just leak my whole password live on YouTube?
That's a lot of characters for Hunter too.
It is that one I just had to memorize. So what's happening here is Ubuntu is booting into a standard Ubuntu install on the main drive. I have a ZFS pool of drives that are connected to it. The ZFS pool of drives has a much longer password, a much longer passphrase. I've created a custom systemd unit that will read that from the TPM on this device and put it into the pool after I enter my relatively simple password. It's the same way that macOS does it with its full disk encryption. Who here uses a Mac? I feel called out. Who here uses File Vault on your Mac? Okay, so when you boot your Mac, what you can do is enter your user password, which is then you enter your user password at the boot screen, which is really a recovery screen. It's an EFI system that looks exactly like your operating system. From there, it will use your input plus stuff stored on the TPM to unlock your data drive. What this means is it's really easy for you to get into your system with a relatively secure method that isn't just your password. And it's very difficult for someone to just pop your drives out and take it to another machine. And because the encryption is not automatic here, it means it's quite difficult for the whole machine to be taken as well. And now, if I wanted to log in like normal, I've completely rebooted a system and decrypted its data from here in California while this system is in a different country. So now, at this point, what I do have is the ability to travel without my data, meaning it can't be seized. I have the ability to back up my data to a system that I control with a file system that I trust for integrity that encrypts this data at rest when the system is off. I can get back into that system via automated configuration management using port knocking and the Nebula registration API. I have an overlay network to securely access these things over the public internet without someone else being able to. I also have the ability to recover that machine if that machine goes down, so I should not lose access unless the site loses access. That gets into more, that gets into site reliability engineering there. How many is too many or not enough? And this now means that I can be relatively confident that at any given point in time, if I needed to wipe my devices, I would still be able to have my data, but no one else. So where do I go from here? What I would like to do is move away from the MacBook for several reasons. And I've just recently bought a Framework Pro 13. I'm so freaking excited about that. Now, this could work on any other system. The framework just happens to be big, happens to be light with a big battery. I think it will be the easiest thing to move away from nice 12 hours on an ARM Mac. I would also like to implement something like Time Machine for Linux. I've already got the Nebula registration API. I've already got modified router with port knocking available. I would like a bit-for-bit copy that restores to the same state that I backed up in on Linux. Perhaps this looks like a NixOS-based system for the integrity checks that are offered there. Maybe systemd boot because it's a bit easier than flashing grub to a different system. Ideally, I would like to be able to restore this to a system that's not the system it was backed up on in case I lose the device at the border. I would like to use ZFS or Btrfs simply because at the file system level, if I can do backups and snapshots, that's a bit easier and more reliable for me. And then lastly, I use Graphene OS on this device, but the backup solution for Graphene OS is not functioning. I would like it to, but there's no root on Graphene OS, which means it's hard to grab the level of backup that I can get from Mac OS. I can't grab my Wi-Fi keys. I can't grab data from outside the user partition. These are particular limitations of just not having root, but I would like to look into this and spend my time on this. So I've gone over a bit of what privacy is, why it matters to me with an anecdote. The anecdote was meant to demonstrate that even though we believe that we have certain levels of privacy, we may not. And I'm showing some ways about how I'm trying to work towards maintaining the privacy, because if we give up that right, it's much harder to get it back. We've gone over a technical implementation of how one might be able to do this. I have some ways that I would like to improve this. The last thing that I'd like to bring up, though, is it's not just the border that we have to worry about right now. Be it flock cameras that track our vehicles when we're moving in public spaces, be it identification laws that are being pushed through governments at state, local, and national governments right now. There are many reasons to be concerned about our privacy, because if we don't have the freedom from disturbance or observation, and if we can't control our own information in its interpretation context, then the rights we claim to have mean nothing. There are several movements that one can go and look for relative to flock, relative to identity verification, relative to encryption and the outlawing of that. I am not a lawyer, nor am I an activist in this room today, but I would like to make people aware that these things are happening, and if we all pay attention, we can make a much better future for everybody. Questions? You.
You seem to be optimizing specifically for border crossing. Once you're inside of a country, then you restore everything and you're back. Is there a particular legal standard for, and I realize you're not a lawyer.
Sure.
Is there a particular legal standard where when you are doing the border crossing, you have fewer rights than you would otherwise once you were inside?
That's a very good question. I'm not familiar outside of the US how this works, but inside the US, it is the case that 100 miles within the border, it is especially in airports, it is considered that you have not actually entered the US yet. You don't have your rights based on the Constitution before you cross the immigration line. And so before you're cleared by TSA, you don't have the right to, you don't have the expected rights to privacy or protections against unlawful search and seizure. There are policies that are meant to uphold this, but case law, that's where someone has perceived a wrongdoing, gone to court, and court has ruled in certain favor, and so that ruling is treated as how we should interpret law. Case law has established that we don't have as many rights at the border as we think we do. Does that answer your question? Yeah. If you want to follow up on that, the EFF has a great document. It is from 2017, but it is still very relevant, about border crossings and what your rights are or aren't as a citizen, as a green card holder, as a resident, and various other statuses. If anyone here would like to look into that question, especially the 100-mile radius question, the EFS document about border crossing is wonderful. Yes?
What kind of router are you using?
I am using a MikroTik router, running the MikroTik's operating system. I would like to move to OpenWRT on an OpenWRT compatible device, simply because it's a lot easier to get Nebula running on OpenWRT than it is on the MikroTik OS.
Think about picking one of those things up here. They have those the one OpenWRT routers.
Oh yeah, the first party routers?
Yeah.
I've heard about them, but I haven't used them.
They're selling them here.
Here?
Yes.
Oh, I should look at that. Yeah. Any other questions? Lots. Yay. You over here.
So I'm just wondering, so since you're doing backup
Yes.
every time you're wiping it, I'm just wondering how long does it take for that? Because I imagine you're going to download like, hundreds of gigabyte of data over like halfway across the world.
So thank you for bringing that up. That's something I didn't get to in the presentation. What I will do, my base image that I'm bringing down, here's a layered system. So on macOS, when you wipe the device, there's still a restore partition. The restore partition is read-only and protected by the TPM of the device, so I can be reasonably sure that that restore has not been tampered with after I wiped the device and moved. That means that the 60-ish gigabytes of the operating system never leaves the device. I have that. What's next is a file system layer backup. That's the time machine backup. And so it's only the diff of operating system plus my data. I have made a time machine backup that is only my applications and critical data. So that's access keys, SSH keys, and more importantly, Resilio Sync. It is a BitTorrent-based syncing application that then allows me to get the rest of my data. So I can get a minimal operating system with access to all of my data and then let the rest of it trickle down. My restore size is about 4 gigabytes, and my restore time on a typical broadband connection is about 10 minutes. Yes?
So you mentioned the PyKVM is twiddling your buttons on your server.
Yes.
Is that a separate, are you wiring the PyKVM into like the power reset buttons then, or is that?
Yes, we can look at that right now. PyKVM breakout power.
So that wouldn't work on necessarily like say a laptop that you're using as a target?
No, laptops do get harder. However,
I mean, you could. But
you could.
Yeah.
Here's a breakout board. What happens here is, how many of us have had a desktop computer that we've taken apart and hooked in header pins before? Okay. So what this does is it will just sit in the middle of those header pins. You'll plug the header pins into this breakout board, and then this breakout board into your motherboard. At that point, the Pi itself can short those circuits for you.
Essentially a wedge.
Yes, yes. And then in addition to that, what I have done is Wake on LAN.
Yeah, that's what I was wondering about.
Wake on LAN would be a good way to do it for a device that you don't want to open up in Frankenstein. But in the event of freezing,
yeah,
there is a long press option in PyKVM, but it's not a perfect option if you're so locked up that you won't respond to it. Sorry, if you're so locked up that you won't respond to a shutdown command. I have seen solutions. I know there are some questions over here. I have seen solutions where people will use Home Assistant-based button pressers.
Yeah, I was wondering about that too.
Yeah. My opinion is if you're going to spend the $80 on a Home Assistant machine plus another $40 or $50 and your time to get a button pusher, you can get a small form factor machine.
Used too, like you can just do like a remotely controlled outlet.
Yeah, yeah, that too.
Oh, the PyKVM will drive a remotely controlled outlet?
No,
No.
You can use PyKVM to SSH into the Raspberry Pi that is talking to your UPS to turn the power off and back on.
Yeah.
How would I know that?
That's kind of what I was curious about. There's a lot of ways to do this.
We do have a couple more questions. I would love to talk to you guys about this more if we want to ideate, but I want to get to the rest of the questions. Yes, you back there.
How did you recover from your privacy breach or your privacy violation?
I cried. No, in that situation, that's one of my biggest concerns here. There isn't a recovery. If someone else has your data, you've lost all control. I just have to assume that all of my data is still being used and still being passed around. I spent a lot of time resetting all of my passwords from my password manager. I spent a lot of time combing through my logs to see what access was and wasn't there, and that's how I found that SSH was accessed. I have no reason to believe that my password manager was, but still, active session, you can get that. I don't trust that the cache on the device wasn't gone. In the event that your system is accessed on this level, I think the only safe the safe assumption is that everything's gone. Yes.
I just wanted to mention you can on a micro tick. You could plug a 5-volt relay into the USB plug and use that to power cycle anything you want if your router's on.
Oh, very nice. You had a question behind.
Yeah. Is the main reason that you're doing the complete no data, like nothing even encrypted as you're crossing, is you want to be able to restore anyways if your devices are taken? Like, so you might as well just.
Well, it's a couple of things.
Okay.
One is, I can't be said to be hiding something I don't have.
Oh, okay.
If it's not on my person, I can't produce it. The second one is, I always want this updated because even if I'm not crossing a border, if this thing dies one day, I would like the ability to have at least yesterday's backup to restore from. And the third is, if I'm not actively testing out the system, it's a critical system that I don't want to be down. So even if I have reasonable assumption that it's going to be fine, I will still wipe and just make sure everything's working. Yes?
Do you have any concerns about them
causing any problems because you've got a freshly wiped machine?
I've had that problem several times. Yeah.
You thought of restoring like a false, like a used, generic used system?
I have. That has been something that's been discussed quite a bit. Something I will do is I will often wipe and restore to a blank system and enable File Vault anyway, just because it makes me feel a little better to think that they're going to be spending a bunch of time for nothing. But I wouldn't do that. I'm unsure of the legal ramifications of that. Where now it's in the lines of possible deceit, and I don't want to be viewed in a bad way if I'm on that side of the jury. Yes?
So like along that line, what about a system that's completely encrypted, but the encryption header, like Lux encryption header, is detached?
Yes.
The disk just looks like garbage. What are the ramifications?
So I'm unsure of how Time Machine implements this. My biggest concern would be that I have to consider that physical access means access. And what that means is if you can copy the data, it's only a matter of time for a brute force to get into it. That time may be 40 years, but it could be 40 seconds. If the data is copied, it's as good as gone. It's harder, but I have to assume that it's only a matter of time, given someone with the desire and the resources. Yes?
I'm curious, you didn't really talk about it, but what are you doing as far as wiping goes? Like, to what extent are you trying to remove that data?
Yeah. So the way that it works on Mac OS is with full disk encryption, you can just get rid of the keys. If Mac OS detects that the keys are not there, it will initiate reinstall. So that means that the data is technically there, but the key's not. What I'll often do is reboot into the recovery environment. This recovery environment of macOS is something I'd also like to implement on a Linux system, but it requires tight integration with the hardware, especially at TPM. When you're into the recovery environment, you can, in disk utility for macOS, you can write zeros and ones to a spinning rest drive, so cleaning it that way. And most SSDs will have a firmware-based, a controller-based secure wipe, which is where they get rid of sector maps, making the data on the drive unreadable even to the drive. You had a question back there.
The same question I was asking, what was your wiping process? You talked about the restore process.
Yeah.
Thank you.
So I'm using the built-in restore environment, but if you're on Linux or Windows, these same things exist in different flavors. You can do controller-based wipes that get rid of the mapping so that either the controller can't read it, or you can just write random ones and zeros. Any other questions? Yes.
Last question, please. We gotta start.
Couldn't you just actually instead of just nulling that out, copy it, and then send it to yourself through another method, and then zero it out, then restore just that block?
The TPM?
Yeah, the TPM.
No, because the user can't write to the TPM.
That would be.
Yeah. I'll be around at the social events. Thank you so much for having
Right.
questions and paying attention. Is there anything here that I should do for Tara?
No, just take your stuff and then I'll be here.
Thank you very much.
Find you later for more technical.
What's up?
Or am I able to find you later for more technical?
Do you use Signal?
Yes.
Use Signal. Are you also wanting to
Sure.
I also said this is dinner tonight.
It's nice to see someone else also using like high KVM. I have like